Speaking of which, pop over here a minute. And then, yeah, I'll let that one go ahead and start to download. So I guess where we left off, and maybe as a quick little review, we were talking about, the importance of having break lines to define our surfaces and making sure that our edges get placed in our modeling. But the most important thing is to, be able to look at this work and look at your results, excuse me, and try to make some evaluations as to, whether the modeling gets done correctly. And one of the things that's really sort of a gotcha when you're doing this kind of thing is, for instance, remember when we looked down the edge of the road and it looked like a bunch of stair steps and it should have looked nice and smooth? Well, one of the things that happens when you do modeling like that and you've missed having a brake line control the way the ground is actually shaped, sometimes you'll notice it, sometimes you don't. And one of the things that happens is, like, if you compute volumes, say against that surface as an existing surface and something else as the proposed surface, what happens is when it looks sort of like a stair step, meaning that it's high in some places, but it's low in other places. And, it's, instead of the nice even slope, it basically has, every foot it might be, 6 inches too high and then 6 inches too low, then 6 inches too high, then 6 inches too low. So what happens is that the volume computations tend to, on average, work out okay, because all the high places will sort of balance out against all of the low places. So things like volume computations and that sort of stuff don't really suffer too greatly from that. But where it really becomes apparent and a problem is if you're trying to work with that surface directly, if you're needing to try to, place something on that surface at that location, because now it's really uh, out of its true position. So again, the key to all of that stuff is just use your eyes and use the tools that are going to help you to evaluate um, what we've been doing with it. Okay. So with that sort of in our pocket, um, as we go along, let's run through a quick little example of something, and then we'll jump into the roadway stuff for the last part of the screen here. Now let me something. Oh, good. Okay. I'm sorry. My apologies. I'm trying to manage something over here before we get things started that I'm trying to get figured out here. Okay, so that is down and in place. There we go. So now they one. Okay, good. Now, sorry about that, and thanks for your indulgence. Now let's talk about a little example here. There is a file I'm going to have you open called example one DWG, and this will have a couple of nice little concepts. It's not too huge a file, and we'll be able to go through a couple of things uh, that will sort of wrap all this stuff up on the surface build. So I'm going to go over to Carlson. And then once this comes up, I'm going to choose open. I'm going to navigate to my folder, which I think I'm already here. That is my 0620 civil class. There's my data sets. And I'm going to look for class example one .dwg and open that. Now, once this is open, it just opens up, looks like it's empty space, but if you do zoom extents, I may not have the right example. Let me see here.
Uh, and I was gonna say, I don't have that one. Would it be just called example
Oh,
one?
yes, I'm sorry. It's not class example one was a little starter file that I started up yesterday. I'm sorry. It is example one. Thank you. Uh,
Oh,
so example one, that's why mine was empty. So there is now example one. There we go. And there's also in there for you to look at later, this example one completed. You can see, what we finished up with now. Here is this. It's going to tell me that the projection state plane 83 Alabama East is currently used in this drawing. We're switching to the less ambiguously named blah, blah, blah. It doesn't matter. I'm going to go ahead and accept that. I'm not really in Alabama, and it doesn't really matter because these points are not on any kind of state plane system. That's just what's registered in the file. So now, uh, what you see here are a series of points. I mean, we talked about what points were yesterday, the symbols, there's a little point at the middle, and then there's this attribute with the point number, the elevation and description. And these are all sitting in with that attribute layout ID of one, where it's number centered above, elevation off to the right, and description centered below. Now I'm going to do something here too that's this is the dead giveaway that tells people that I truly am one of those nerdy engineers, but I just really can't stand this ugly looking text in this manner. And here's where you can change it. If you ever get to, and the reason I point this out is that sometimes we can use these points and the descriptions, maybe freeze the numbers and the elevations, but leave the descriptions, and we can um, use those as part of our finished drawing. And we don't really want it to look like, stick figure kind of drawings. So this is showing in that particular text because of the text style that was used when the point was created. When points are inserted into a drawing, they use a text style called PTXT, called point text. And if it does not exist in the drawing that you're putting these in. If that style has not been created yet, the process of putting a point in there goes ahead and creates it, and it just uses that standard old font called text.txt. And it was back from the old days when we had pen plotters. And so it's a pretty fast and efficient font. That's why all of the rounded shapes are all squared off, because that was the path that a pen, excuse me, that a pen would travel in a pen plotter. It was a lot more efficient than trying to make a smooth circle, because pens can only go up, down, back, and forth. They're not raster devices, so they had to trace all that. But anyway, enough of that. So all we need to do is redefine that text style to use a different font. So if you go to your draw menu and look at the text full right, and then come down and choose set style, or just type the word style in the command line, you'll get this dialog box that comes up where you can define multiple styles of text. Right now, there's only two. There's one called PTXT. That's the one the point uses. There's one called standard. And you can see my standard text uses this font called Roman S. That's Roman simplex. And that's the actual font name. What we're talking about over here on the left are style names. So the PTXT, there's that txt.shx it's a shape font as part of AutoCAD, but now you can use any fonts, including these nice true type fonts. And one that I like to use that I have installed here is called Calibri Light. And if I do that and then close the dialog box, you can see how the points now show up. A little nicer looking font. Kind of deal. So totally unnecessary and completely cosmetic, but there it is. I'm gonna pull this way a little bit just so I can keep my eye on that icon down there. Now, so what do we have? We got some points. Now, this also illustrates something that can commonly happen, particularly if you get files from somebody else. They might send you a drawing file that has points in it. Well, don't make the mistake of thinking that you've got those in a point file somewhere. Right now, they only exist in this drawing, but they don't exist in a CRD file. In fact, if we look up at the top stripe of our application, we see we're running Carlson Survey 2024 with AutoCAD, not for reason, that's my license. And then it says CRD, none. And then it says example 1.dwg. So I don't even have a coordinate file open. But so, you know, what does this mean? How do we get those points from our drawing into a coordinate file if that's what we're going to use? In fact, if you try to do, oh, let's just do a simple thing. Say, we're going to draw a line between point 2020 to 2025 and connect all those points together. So if we go to draw 2D polyline and we say, okay, and it asks us to, down here on the command line, you see it says pick a point or point numbers. So if I try to use my point numbers, 2020, 20 through 2025, see what it does? It doesn't go to the drawing for these points. It's looking for a coordinate file. Well, I don't have it. I don't have points in it. So even though they're in their drawing, we need those in the file. So I'm going to escape that command now just to show you the next place that we can look at this. Now, there's a couple of places. On the points menu, all the way at the bottom is a point utilities full right menu, and there's all of these different utilities. Now, most of these, if not all, I haven't really checked, but almost all of them are also contained right up here at the top part of the menu where it says, and it looks like a little Swiss Army knife. These are our coordinate file utilities. And when I run that, it's still going to now ask me for a coordinate file because I have yet to associate a coordinate file with this. So I'm going to click on the new tab, and I'm going to call this one just the same as my drawing, example 1, and choose and hit enter. And so now I've got a point file associated, and you see it's repeated up here at the top, but there's nothing in it. I can do list points and say that on. It shows me I've got 0 points. And notice that is the same command as on the points menu to list points. And so here's what this tool has in it is on the left-hand side are things that are going to work on the coordinate file. In fact, it's headed up as file utilities, whereas on the right-hand side of buttons, there's a column that it's titled point utility. So this tends to work on a point or a group of points within this particular file. These other file-based utilities are things that are going to let us work with this file and other files on a file level. So if you come down to the bottom, you're going to see 2 commands, one that says update the drawing from a drawing file. So if you, or from a coordinate file. So if you got a coordinate file with points in it and you've got a drawing that doesn't have those, you can either do a draw locate points that like we did yesterday and read the file and put them in there, or you can say update the drawing from the coordinate file and it will do that same effect. This is a separate command from draw locate points in this sense. Like if you have these points, say 20, 21, 22, 23, but they've been moved, but had not been updated in the coordinate file. So they're now also existing in the drawing, but maybe in a different position than what is defined in the CRD file. So that's what would happen is the update drawing from CRD file command would go and read the CRD file, find out those positions, compare them to the positions of the points in the file in the drawing, and move them back, move them to their proper positions. It can also check against uh, if you've got some points in the drawing, but you've got maybe some of those points don't exist in the CRD file. So you can basically just bring it into sync between the drawing and the CRD file. So the other command, the one on the bottom, is the one that we're after. We're going to update the CRD file from the drawing. So we're going to read the points out of our drawing and put them into this CRD file. So let's go ahead and choose that button. And you can see you've got some filtering you can do here with a wildcard, description, math. We're going to use, the asterisk that just says take everything. These are any custom attribute names if you wanted to call them, if they had different names, but this is what those attributes are named because they're Carlson blocks. So we'll say, okay. And now if you look down on the command line, it says select objects. And the line above it says select Carlson software, LDD or Land Development Desktop, or Softdesk, which really they're the same. Inroads, those that from a Bentley file, if you're using a DGN file. Eagle Point, Geodometer, Leica, or Microsurvey point. So if you have any of those other points from those other software applications in this drawing, it will read those as well and create Carlson points out of them. So it says select objects, and that's all that's in my file. Oops, sorry. So when I choose this, and it asks me to select objects, I can just type the keyword ALL, hit, which is all, hit enter, tells me it found 240. Now that's not to say there's 240 points. Remember, a point has 3 entities. It's got a point, it's got a symbol, and it's got the attribute block. So 240 would be 3 times 80. So once we do that, now it's read those in, you see the line above on the command line, it says testing entity number 240, the points found 80 points. So it found 80 points out of those 240 entities. And if I list my points now, go back to that command, I see I've got them here from 2000, and they go all the way down here to 2079. So that's 80 points. And look at the descriptions. I got B dash toe. I've got B for whatever that stands for. Now I'm going to go ahead and get back to this utility and choose exit so I can finish that command. But when I start to look at these points around my site, it looks to me like, and this is in fact the case, that all of the points around the edges are called B dash toe. Okay. So that's the toe of the bank or the, whatever this is. And what this is, by the way, let's go ahead and view this in our 3D viewer. And it's on the view menu, 3D view. You can see it doesn't. Can you see those okay on your end, somebody? It looks kind of faint on mine. Maybe I need a different color. Let's look at this point mark. Let me make that a little brighter. Something like that. Let's see if that does anything for us. Probably won't, but anyway, so when we view this in our 3D viewer, you're going to see that it is, there's a series of points and they are sitting around in space and they're sort of, it's sort of flat. I'll run up my vertical exaggeration over here on the side so you can see now it's, you can see that it's just a mass of points and all the points in the middle are piled up and all the points around the edges are sort of at the lower elevations. You can see that maybe like that, you can see better. Okay, so what this happens to be, by the way, is just a little stockpile. Okay, it's not a very tall one, but it's basically a stockpile. So now if we were going to do something like compute the volume in this stockpile, there's a number of ways we can do that too. We first of all are going to at some point ultimately need to make a surface out of this. And you can do it, several ways. And there's also on the civil menu, let me switch back to my civils. There is on the surface menu of the civil module, there's this little routine right here that says stockpile, pond, and pit volumes. And it allows you to do that. It's sort of a specialized command that calculates the volume of a stockpile or of a pond or a pit. And I don't tell people even to really use that command much at all. A lot of people do it because they think if they're using a stockpile, then they have to use that stockpile command. Because this is a routine that basically does the same thing that you would always do anyway, if you're going to compute volumes between any two surfaces. Okay, so what we're going to do is we're going to model a surface out of these points, and then we're going to calculate the volume that is within that shape as if it were sitting on the ground. Now, for those of you who are thinking ahead about how this works, when you compute a volume of any kind of a surface material, you have to model the surface of that material. And keep in mind, when you model that surface, you're going to be creating triangles and they're going to lie up on the surface itself. Well, how can you you can't really compute a volume between that surface and empty air. You've got to know something to compare that surface against. So you would need, a reference, either a reference elevation. So then you can take a look at this surface that we compute and see how far it is above or below our referenced elevation that's flat and horizontal, or you need an approximation at least of what the natural ground would be like underneath this pile of material. And when you think about that, we're going to actually make two surfaces out of this uh, set of points. Because if you were to think of that stockpile as sitting on native ground that is um, something around out like this, and it has some kind of um, there's some kind of shape, along the ground here, but then these points are then sitting on and above that shape. So we need to somehow figure out what that is going to be. And the only information we have now are these points. So what would this information be? If you think about these points and the stockpile that it would be, if you sort of imagine yourself as a giant holding a spatula, and you're going to slide that spatula underneath this pile of points and scrape it off of this ground surface here. So what is that would represent is we're going to say if we've got this outside edge around our points, that represents where our points are sitting on the natural ground. So if we take all of those points and just say, we'll make a surface edge to edge across the bottom, and it's going to be fairly flat, right? Because it's going from one edge straight across the other edge without any kind of deviation in between. And it's not necessarily truly what the original ground looks like there. We don't really know, but that's the safe assumption that we're going to use. Okay. So I'm going to show you, we're going to step through some of these exercises, and then we're going to design a little um, building pad. We're going to use that command to start looking at some of this grading and then how that compares into this, and how we're going to start stitching some things together. And then we'll jump into the rest of the higher end on the road side of the things. But right now, just to get some practice here. So what would we first do to make this surface? If you remember from yesterday, we did our surface menu and triangulate and contour. And if we do that, we're going to make sure we're going to write the file. So I'm going to choose select. I'm in my folder, and I'm going to call this just SP for stockpile. Okay. I'm not going to draw any of this stuff in here. I'm going to ignore zeros, and I don't have any inclusion. I'm going to not check this use inclusion exclusion. I'm going to shrink wrap perimeter reduction to none. Leave that as that is. So none of these other things checked. I'll go to my contour tab, and I'm going to uncheck to draw the contours. I'll look at my selection tab, make sure nothing is filtered left over from the last time, and it's not. So then we're good to go. We're going to say okay. And it says select objects. Reading the line above it, it says select the points and the break lines to triangulate. There are no break lines. It's just a bunch of points. So I'm just going to grab these points. Off it goes. Nothing happens other than it tells me that it made that file. So now if we go to the view menu, the 3D view and surface file viewer, and let's look at down in our recent list or out of our list here in the current folder, let's choose that SP surface. So if I look at that, up it comes and says, oh, okay, great. We've got a surface. made up of those triangles. But here's something to point out that we can see. Go ahead and exit that. If you go to your surface menu and go all the way to the bottom section where it says draw surface, let's just draw the surface boundary. And if we do that, I'm just going to take these defaults here and just use a 2D polyline and choose OK. We'll choose that file. And now there's the surface boundary. Doesn't look too bad, right? Fairly close, but take a look at what has actually happened in certain areas. Right in here, it says the edge of this surface comes along this line here, but I see that it really should go from 2017 to 2018. So technically it should do something like this. Well, the right command here, add a vertex. So it should look like that, right? But it didn't. And down in here, for instance, it should have jumped up to this one. Okay, over here, you see how this line comes into here, so it should have all been, if I go to, let's go to my, and uh, point, so that one should really have, say, followed like this. Okay, everybody understand that? So we had this extra area out here that really is not part of this surface that we've included. Okay, now we don't know here, like from here straight across to here is probably correct. We don't have anything else in the middle that suggests otherwise. We just got all these B points. Okay, so we could something this small, we could just go ahead and add these few things into it and then use that as a boundary later if we wanted. Here's another place in here. You see these toes where it should have kicked in and followed those points around. Okay, so right now the surface is, in fact, if we also go to our surface down to the bottom, draw surface, let's draw the triangular mesh and choose that. You can see here's where these outside triangles formed, where that it should have gone in to those B toe points, but it didn't. So here's this long triangle out here that shouldn't be part of it. Here's all of these triangles in here that should not be part of it. Here's all these triangles in here that should not be part of it as well. Now, a lot of people's practice, oh, and the one up here. So a lot of people's practice would be to edit the surface and to go through and erase all those triangles and then save that surface. But again, let's try to figure out how we can do this without making a direct edit. Let's just fix the data so that when we are, if we ever have to rebuild the surface, we're not going to get those. We don't have to worry about those happening. Okay. So I'm going to go to first edit, erase by layer. I'm going to choose select layers from the screen. I'll pick that layer, which was T-mesh, and clear that out. So if you remember, what we need to do is put a boundary there as part of our data set and then turn on that switch to use inclusion or exclusion areas. And so that is our shrink wrap boundary. And you can do it in here or you can do it as part of that command. But if we draw it here first, let's choose draw, shrink wrap entities. Okay. And we're going to tell it we want to go across gaps so it can jump the space, across these different areas. And we'll set our perimeter reduction value to medium. That's a good one to check to see how well it's going to tighten up. That should be okay. And we'll say, okay, it now wants us to select our data. So we're just going to draw a window around everything. And now there it is. And you can see it follows toe to toe to toe, jumps in here, finds toe. And as I go all around the edges, I see everything's good except right in here. Oops, there's one place where it shouldn't have gone. And you can do something as simple as this one is to just, select it, get your grips showing, and then, why is it not? Oh, it doesn't come up and say remove vertex on that particular one because that's actually where it started. So that's the start and stop point of that. Um, so it won't work. It won't respond to the grip editing tool. So if I go to edit polyline utilities, remove polyline, and then remove polyline vertex. If I select my line and then just click nearest, that point is still, huh, still not doing it. All right. So let's just select that. We'll drag it out here. And then we're going to actually break the line. All right, couple of things. I don't want to take all these side tangents, but here's something that might be a useful tool for you to know about anyway. The reason that's not allowing me to work on that vertex and take it out of that line is because if I'm going to go over here in my properties, and let's look at our, it's right up here. You see that little X marker? That's where this vertex 1 is. And if you go around, you see how it moves. And I'm going to go back to, there's my start and there's my end. My current vertex 31. And then if I go back, you see there's 30. So it actually has that vertex where it ended, but because it's specifically the starting or stopping point of that polyline, it doesn't let me manipulate it the way I want to manipulate that particular one. So one thing you can do to be able to work on that with with the grip type tools is you can change where that polyline starts. You can change its origin. Okay, so if you go to the edit menu, the polyline utilities, and you're going to come to this edit polyline pull right, and you're going to set the polyline origin. So when you choose that, it wants you to select the polyline, which we'll select, and it says now pick near the new origin point. So you don't have to snap to it, just nearest the one you want to use. So I'm just going to drag it down here and say, I'll click there. And so that now is its new origin. It asks me now to select it. Now the polyline, if I'm done, it says enter to end. So I'll just hit enter. Now I've got this polyline. I select my point number 1, you see where it is, and the point I'm interested in is now vertex number 3. Okay, so now I can select this and just hover over that grip and it will say remove vertex. And so now I've taken that indentation that went in out of this polyline. And if I keep scooping around here, I'm going to look, it goes from the B toe to B toe to B toe to B toe to B toe. I'm just making sure they all hit all of those TOE points. And it looks pretty good. Here's another case where it came in too far. So I just hover there and remove the vertex. And we're going toe to toe to toe to toe to toe. So that would really be a fine way to do that. There's other ways as well. You can um, you can look at the point numbers, for instance, and see, all right, I've got point number 20, 30, 31, 32, 33, 2004, 03, 02, 01. All right, so starting in 2000. So starting at point 2000, 2001, 2002, they appear to be in sequence, in proper order. If I go to my points menu and list my points, just list them all, I see, okay, starting with 2000, that's my B toe, goes all the way around to 2028. There's B toe. And then everything else is a B. So to keep from having to do any editing, if I know that, I can say starting with 2000, going to 2028, I'll go ahead and erase that now. And I can just say, draw a 2D polyline. And I'm going to uncheck this. I'm going to put it on a layer called BDY. And I'm going to say, okay. And it now asks me pick a point or point number. But remember, we saw that it was point 2000 through 2028. So 2000-2028, I hit enter. And there it is, drawn all the way around. And now to finish that, I'm going to type C to close. There it is, done and closed. And let me make this so you can see it a little better on the screen. And let's turn it on. Oh, there we go. All right, so there it went and only connected those B dash toe points. Okay, so that's a way of doing it. That's certain without any edits, but you had to have known that about those point numbers. Supposing you didn't know that, or supposing that, you excuse me, you wanted to find out what it was. So you could, make points only. Let's say if you didn't want any of these B points to be in there, you could erase all these points and then draw back from the drawing or from the coordinate file just those with the description, and then connect those points up. Or you can do, if you look on the draw menu and come down toward the bottom where it says polyline, and if you say polyline by nearest found, I'll do it 2D. I'm going to put this on my layer BDY. And if I say okay, I think, no, this is not the one I'm looking for. There's one where we can draw this based on base it on our descriptions. Let me see. Should still have been polyline by nearest found. Oh, here, I'm sorry, I blew right past it. So in the description match here, so if I wanted to not look at the ones that say B, but I do want it to look at the ones that say B dash toe, then I can say this has to match that description as B dash toe, or I could just put, asterisk TOE, just it starts with anything, but it ends with TOE, that kind of thing would work. I'll choose OK. And now it says select the points you want to consider from the screen or by a point number. Well, I'll just take it from the screen and I'll just type all to get all the points, including the B points. And now you can see it started wherever it found the TOE and it went to the nearest one that it could find with that same description, ignoring the B's. Now, one thing I do have to do is to select it, go to my properties, and down at the bottom, make sure that it is closed if I'm going to use that as a boundary for my surface. Okay. So all of those ways are just different ways of doing that, drawing that boundary. You could also just let the command do it itself. But anyway, I just wanted to point out some of those tools that might help you out in some situations. Again, in a situation like this, the site is small enough, you'd be done in 20 seconds just by, click, 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 click. You don't have to worry about this. But if it's a huge site and you're trying to really figure out, what's been going on with it, you can use a tool like this. Now, sometimes
Hey,
also,
Ken,
yes,
can you show me again where you find the polyline by nearest phone? I
yes.
missed that part. Where is
Okay,
that coming?
I'll go ahead and take this off. It is on the edit menu. I'm sorry, the draw menu. Because again, I'm trying to draw something. So I'll go to the draw menu and I come down to the bottom where it says polyline and there's a pull right.
Oh, okay.
And there it is
Thank
by
you.
nearest found.
Yeah.
And this is what I missed the first time is right in here where I can put that description in. So anyway, so there was that. Just take them all. And then also once it's drawn, come over here and say close. Now, one thing you have to be careful of too is, let's suppose like right here's a B toe point, and let's see, maybe there gives a better example, like maybe here. So if this B toe point was say, um, way over here, and it was obviously that it should have been part of that outside, and it goes way out here and then comes back. So it might draw this incorrectly. It might come out here and get to this point, and this point, or this point down here would be closer than this point over here. So when it says nearest found, it really does honestly go to the one that's next closest. So it could sort of, crisscross and not go in order. So you got to be a little careful of that. But this one worked for us just fine. Okay. And again, something this small is not worth all of the additional analysis. Okay, um, so now we've got a boundary to use for our surface. Let's go ahead and build that surface. So I'm going to go to Surface, Triangulate and Contour. And everything is still set up like it was before. We're going to write the file and it's going to write to that sp.10 and it will ask if we can override it. That's fine. But I'm going to turn on now this little checkbox that says use inclusion, exclusion areas, and I will trim the edges instead of removing the entire triangle that might cross it. So that's what we want to really just like cookie cutter it right out of our material. Okay. And let's see, nothing much else to do with that. And we'll choose OK. Is it okay to overwrite the existing surface? Yes, it is. And now reading the prompts, it says select objects, but read the line above. It says select the inclusion perimeter. So I'll select that. And you can have more than one inclusion perimeters, by the way, but there is only one here for us. We'll enter to finish the selection. Now it wants to know any exclusion. And by the way, for those of you new to this, exclusion perimeters are places where you define by closed polyline areas that you don't want to build a surface under, like underneath the footprint of a building or the outline of a pond or something like that, because you don't know what that surface is like underneath those outlines. Okay, so and it just leaves them as undefined areas. All right, so in this case, we have no exclusions. So, so we hit none for that. And now to select the objects, we'll just grab all of this information. And we've now built the surface. And if I do this, here's a little trick for us. If I go to view, 3D view, my drawing viewer, remember that takes things out of my drawing, not the surface file. And I select everything and I get into my viewer. Well, there are those points. Okay. And if I go to the right-hand side where those panels are and I choose that model tab. Notice I've got here some things I can, points on and off if I want to see the points, polylines, but surfaces, you see I can add surfaces into this same session where I'm viewing this series of points. So if I right click that and choose add surface, or you can pick it from the icon up above, which is that right here, add surface. I will choose that surface and choose open, and now the surface gets placed in here, and I can look around there and you see those points that are down around the perimeter of our surface, and we can see there's, in fact, you can toggle the triangles on and off, maybe see the points better. So that's how all of those points got made and made part of the surface. And I don't have those other long skinny triangles out there that are causing issues. Okay. So it's a nice way to verify what we're doing here with our surface. We've built our surface here. Now, what do we do with that? Well, we can draw the contours of it. We can compute its volume, which is what we're after, but we need a separate surface to compute that volume against. Or let's say if this were a stockpile sitting on the, the flat ground and we're in the middle of Kansas somewhere, and I might come down here and look at one of these toe points and I'd say, all right, I'm going to assume that I've got a 390, up here's 391 and a half, there's 390. So if let's say I was at a 390-foot average elevation around the edges, then I could use that as a reference plane to compute the volume. Wouldn't be all that accurate because that assumption that that plane is level is not necessarily true. I mean, this stockpile could be sitting on the side of a hill slope, In fact, I see I've got elevations over here at the 393, 94, 95, 96, 96 and a half, 96. You see it, and then it drops back down 94, 95. Here's 97, 95, 90. So, there's some real variation in those edges. And in fact, right in here, this goes from 95 to 97 and then back to 95. That's probably, I'm going to guess, it's probably an error because it causes a little bit of the error in our surface computation when we do the volume because it sort of ticks up at that corner, and we'll see that in a minute. All right. So if we wanted to compute this volume, we need another surface to compare it against. And the only surface that we could assume would be if we took this line work here and disregarded all of these points in the middle and only made a surface out of these points around the edges, and it would just go edge to edge, the triangles would form all the way across this thing without hitting any of these points in the middle. So that would be our bottom surface. Now, how do we do that? How do we make that point? One thing you could do is you could erase those points, or there's a command under points that says freeze points, and you could freeze all of those different points and the range of points. You can make a point group, or you can say description match, and you could type B. And then if you say okay, well, let's see. Didn't work. Let's see, freeze points. Oh, I'm going to choose all first instead of I let that range in there. But I'm going to match description B. And so it says, okay, do you want to freeze the symbols, the line work, any text? Symbols are really all I have on there. So I just say, okay. And now they're frozen. They still exist in here. And the only way to get those back is to unfreeze them. So that's one way. I could then make this surface just like we did before and do it that way. or I'm going to come back to points and I'm going to thaw my points now. Instead of doing it that way or erasing the points and just restricting it to the points, remember our discussion about using break lines means that it's not just reading points, it's reading the elevations of of line work as well. But when we drew our line, remember what we did? That line is 2D, right? And it's down at 0. So it's not at these 391 type elevations. We come back to this. So a couple things we could have done differently is instead of making that a 2D line, when we drew polyline by nearest found, we could have made it into a 3D polyline and it would have taken on the elevations of those points as it found it. That's one way of doing it. But now, and the other thing is when we draw a shrink wrap entities, we come down here and you see across gaps, we've kept it like that. And again, like the other command, 2D or 3D, we could do. And if we say 3D, then we could either ignore zeros or elevate things that happen to be 0, but it's going to take on the elevation of everything it finds as it wraps around there. That would work, except let me put this back. Okay, there it is. So that would work fine, except in the case where we need to add some different points in. All right, so that doesn't really get us to that. You can simply draw a 3D polyline and click your way around all of those different places. And again, when you snap to those points, it's going to read that elevation and set the vertex elevation of that polyline to match that of the point or whatever it's touching. Okay. Now, all that being said, let's suppose we've done a nice, pretty complicated 2D polyline as we're laying some stuff out and we want it to really be a 3D polyline. Well, there's a nice simple way that Civil gives us to do that, and it's what we call elevating our data. And this is particularly helpful when you do something like um, if you're drawing break lines. In fact, let's put a little bookmark here for a second. I'm going to open up this file that we had yesterday. And you don't need to do this. I'm just showing this as to one of the ways we can do we can use this technique. Okay, so I'm going to freeze off those and let's say those commands. So now remember we needed to have a break line that went down through the peaks of all of these contour lines, and they need to sit at that elevation. Well, that's that's fine. Let me find a good, right in here is a nice place. Let me, okay, so this is a nice place to illustrate this. So if you're drawing a 3D polyline, you're going to draw the break lines in yourself. So I go to draw 3D polyline, and I'm not going to prompt for the elevation or slopes, meaning I'm going to let it read. And I'll put this on a layer called uh, BKLN. So I'm going to start putting in these break lines that are going to connect the tips of these contours to the tips of the next contours. And notice when I'm doing this, you know, it's reading. If you look down here on the bottom, you can see it's setting the Z values as I go. Okay. So, but now watch what happens in this particular case. I'm going to click there. I'm going to click there. Now, what I need to do to go from the tip of that one to say this tip over here, but you see I'd be crossing this one. So I need to sort of go around that one before I come back to that. So if I were to do that, I have to do a couple of things. I either have to click out here, and if I click out here in empty space, and now I'm ready to start snapping. Now look at this when I'm going to select a few of these things and show you how this all lined up. Because you'll see that where I started, it all worked okay. But I got to those places where I clicked outside of those places where it snapped to the contour lines. And so the elevation that it read from empty space was 0. So now that line, which you can see like that, you see what it did? Those are those places that it didn't snap onto it. So I need to, you know, then I would need to come back and edit that file to set those up. Or I can go to do something like this. If I draw a 3D polyline, and if I go, you know, here to here to here to here, and now I want to go around that little piece there. And so one of my options down below here is to um, well, it's not giving me that option at this point. Let me uncheck this for a second. All right, so a 3DP. So I'm sorry, I needed to turn this on to prompt for elevation and slope. So if I do that, and now I go from here and I click there, and instead of starting to draw, it wants me to confirm the elevation. So I'll hit enter. I'll click up here, confirm, hit enter, click here, enter, here, enter. And now I want to go around that. So one of the options now is to, if I pick outside of here and I want it to not be 0, I'm going to click, and now it says, okay, what do you want to do about the elevation there? And you can either set it by a percent slope, by a ratio, by elevation, degree by both, or you see where it says interpolate. That is in my little angle brackets here. And so I'm going to just type, you know, I to interpolate. Oops. And it says, okay, this point elevation will be interpolated after you complete. So now you're going to keep interpolating. It's in brackets, so I just hit enter, hit enter, hit enter. And now I'm going to go right here and click that. And now it offers that elevation, which I will accept. Now all of those other interpolated points are interpolated between this contour line and this contour line. So that contour line there is 1296. That contour line is 1297. And if I look at my elevations here, I'm just stepping through at that last one. You can see the elevation is 1295. I'll back up one, there's 1296. And now it's going to be interpolated. So I'm at 9608, 9628, 9643, 9654, and then finally 97. Okay. So that's one way you could have done it, but you're constantly, click, hit, click, enter, click, enter, click, enter until you're trying to do that. So the easier way of doing this whole thing, which is where we're headed with this discussion, is I'm going to draw that first as a 2D polyline and not a 3D. And so I'm just going to click there and there, there, and there. And now you can click your way around that little spot. In fact, I'm going to go ahead and click over here. I'm going to come back to fix that in just a second. So I'll click there and then finally, now I'm done. Now, I've gone ahead and crossed right here, and that's what I wanted to avoid. So if I select this, get my grips to show, I can come in here now in this midpoint grip, right click and add a vertex. So let's add a vertex, and we're going to put that vertex, say, up in here. And I can also do something like maybe just convert that to an arc, and then I'll convert this to an arc. So there's all kinds of, different, let's put that back as a line. I didn't much care for that. Let's add a vertex first. So we'll put a vertex in here, and then you could add, convert that to an arc. So you can do, some nice little manipulation of a 2D polyline that you can't do with a 3D. But now, how do you get the elevations to be assigned to that 2D polyline? And that's the point of what we're doing, is we're going to elevate. So we're going to go to the 3D data menu and choose 2D to 3D. Now we have to tell it by what method. And so we're going to use screen entities. So when we do that, it's going to take that 2D polyline and if we choose, let's see, select the polylines to convert. So we'll select that. And now select objects. It wants to look at the 3D things you want to consider. I'll just type all. And now it is a 3D polyline. And if I look at it in conjunction with these other things in my viewer, there I can see how it's, started at this elevation and it worked its way all the way around to, I didn't capture the other contour lines, but you'd see how they snapped right to it. And then it just interpolated its way around to, between this last one here and that other one there. Okay. So that's the tool to use. And I find it a lot of times so much easier to draw a 2D polyline and then raise it up based on what it touches. So I'm going to put this guy away and come back to our example. And let's do that same thing. We've got a 2D polyline here, but we need to raise it up to be 3D. So if we go to, and the reason we're doing that is so we can build a surface out of it without having to restrict all these points, to freeze the points or erase them and gather up the points, carefully select them. We're only going to use that 3D line once we get it done. So let's go to the 3D data menu and choose 2D to 3D polyline. And you can do a couple things. You could say by screen entities because they are on the screen. However, they also happen to be points. So if we choose that by points, you could, filter your descriptions. Set the layer name for the 3D polyline. Let's just, we'll keep it on boundary. Select the points by point number or by screen. It doesn't matter there. If we No real need to filter descriptions at that point, but we say okay. And it says select the polylines to convert. Well, I'm going to use this polyline. And the point numbers, I'm going to type just all. Hit enter to finish. Now it says changed one polyline. And if you look at this now in 3D, unlike before where you saw the polyline stay down at 0, it has magically gone through and attached itself to all of those peripheral points and set those elevations accordingly. Okay. Everybody see how that worked? And now you've got a 3D polyline. If I select it and look in my properties, I see it's a 3D polyline, and I see all of the vertices have those differing elevations. Okay. So now we need to make a surface out of that 3D polyline, which couldn't be simpler, and we'll call that one our base. So if we go to Surface menu, Triangulate and Contour, and let's write the triangulation file still on, but we need to change the file because we want to keep the stockpile surface. So we're going to hit the Select button, and this time we're going to call it Base. Okay. Use inclusion and exclusion areas is fine because we'll set that up accordingly. Ignore 0. Everything is all good. We'll say OK. And now select the inclusion perimeter polyline, which is that one. Okay. There are no exclusions. And now it says select the points and break lines to triangulate. Well, we don't have to select each individual point because this line contains vertices that are at those same elevations, at those same locations. So I just simply need to select that 3D polyline and nothing else, and hit enter, and off it goes. It created it. If I look at that in my surface viewer, there's my base. So there is, you know, all those triangles that went edge to edge across that from that 3D polyline. Now you'll notice there's a couple of here. Remember I told you that one point that I think has a bad elevation right in there. Okay, so that's gonna make us have a little wrinkle in our volume comp, just a little bit in there, but it's not very much to worry about. Certainly nothing that would hold up any kind of production work. All right, so now there's our base. While we're still in this viewer, I can do a couple of things here. Let me rearrange my. If I want to look at this surface, along with at the same time the other surface, well, I can go to this model tab on the right and I can add a surface, and you can add more than one. So that was base. There's SP. If I choose that, it comes in. So I now have two surfaces shown in my file. And right here's where I was pointing to. You're going to see a little bit of difference in the comp right in there where one sort of bleeds through the other. Okay. In fact, and again, like I said, it's not much to worry about. Now, what can we do? We've got these two different surfaces. And if I open up the expansion, I see I've got the base, I've got the stockpile. And if you check down here at the bottom where it says double click the surface to toggle the visibility, if you have that option, then you can just double click, one on top of the other. In fact, I'll show this here like this. Maybe I'll turn on and off the stockpile so you can see it there like that, right? You can also right click and choose edit surface properties, and you can give it some transparency by sliding this opaque button or slider down. So now you see that is, you can see through that surface and you see the bottom underneath it. Okay. All right, so I see what's going on there. That is the stockpile. Okay. So if I were to now, let me see what that did for us. Okay, maybe that'll be a little better. So now you see I'm looking through that stockpile material. I've got the base on the bottom, and I fixed that little glitch in the corner. Okay, if you are curious as to what I did with it, I did what I told you I don't normally do, is to make a direct edit to a surface. But I saw how that the triangle edge on the one surface formed 90 degrees in relation to the way it formed in the other surface. So what I did was I turned off my stockpile and I had this, and you see this long triangle here? Maybe it's easier to show this long triangle here. I did what I go back to my view control, I select my arrow, and because I'm reading a surface file and not a series of things from the drawing, I can now do surface edits from within this viewer. So I'll grab that icon, the arrow icon, and I look now that I have that and I have these particular things I can do. And it's what's called swap a 10 edge. And if I double click this line right here, watch what happens. It forms the triangles in this direction. If I double click it, again, I can make that change. So before it looked like this, and if I go back to my model and turn on my stockpile, so now you can see how that is sort of, see how I can see that the base is sort of sticking up through there because my stockpile has this, you see that direction right there? That's the triangle direction of the stockpile, whereas the triangle direction of the base is this way. So what I did then was to go back to my model tab. I turned off my stockpile and I want to swap this direction so it doesn't form and come up out of the ground. So I come back to view control, grab my arrow, double click that triangle, and now it's swapped it. I'm going to come back and put back on the view, and you can see that now should give us some good results. I can now compute the volume between these two surfaces. So now if I say exit, it should prompt me to save changes. Yes, I'll save the changes, and I'm going to, let's see, it was the base that I changed. So I'll save that. Yes, I'll overwrite it. Okay. So now we've got those two surfaces. How do you compute the volumes? On our surface menu, second, I hit the add new drawing button instead of the menu. So under our surface menu, we have a section in the middle that computes volumes, again, by triangulation as opposed to gridded surfaces. And so I go to my volumes by triangulation, and I'm going to do a 2 triangulation surface volumes. So I'm going to do that and choose, first of all, it's, select a file, but it says up above in the stripe here, select the existing surface triangulation file. Well, that is my base. So I'm going to choose that and hit open. And now it's going to pop right back up with the same dialog box and select the surface. But we read the top up here. It says select the final surface. That's my stockpile. I open that. And now it wants me to use any inclusions or exclusions. Now, you don't need to use any inclusions because that's the extent of the surface. But you could say restrict it and only do a subset of those two surfaces if you were interested in that, like a phase boundary that you might have on the interior. So you can make the computation fall within those inclusions or not. So I'm just going to hit enter, enter for the exclusion. And now here's my volume information, cut and or shrink and swell factors for cuts and fills. If you know what they are based on the material, you can particular units that you may want to see, either cubic feet or cubic yards or both. You can calculate tonnage. Let's say if we know that that's a stockpile of coal, it might be 80 pounds per cubic foot, or if it's limestone, maybe 105 to 120 pounds, or whatever it happens to be. Let's use coal here. And then we'll say, okay. And it's going to come up with this result. Now we're going to talk about what this means here as well. Because this is, although it's a very simple and quick calculation, there's a lot of information about this when you're doing volumes. Now it computed the tonnage and gave me a cut ton of nothing and a fill tonnage, meaning how much material. I've got 3,600 tons in my materials here. So it's 3,363.90 cubic yards at 80 pounds per cubic foot. It turned out to be 3,633 tons. But now here's sort of the interesting information that it does when it sums this up. It takes this combined area, which is obviously irregular, and it, shows you what those areas are. There's our total inclusion, 25,000 square feet. And then it's this part right in here. There's an average fill depth and cut the fill ratios, etc., and a total volume here. So it's taking this irregularly shaped area, both in terms of its horizontal footprint and its vertical extent, and it's showing you the resulting equivalent rectangular prism. So it's saying if you had if that site were little rectangular edges and it were a constant depth of an average depth of 3.61 feet, then those would give you those same numbers. So they're saying, okay, to go from existing to final, which we said was stockpile, you'd have to bring in 3,364 cubic yards. Well, that's fine. But it says if you take that equivalent rectangular prism and say, how much would you have to change that elevation to make it balance, to make the import and export, which our export is 0, but it would make it be the same number. And that is, you'd have to lower the site by 3.6 feet to make that balance into the same amount of cut versus fill. So it doesn't make any sense on a stockpile, obviously, but you can see what it happens. And here's the key number, is this volume change per 1/10 of a foot. So if you take your site on average, because it computed that average rectangular prism, So if you take your site and every 1/10 of a foot that you raise it or lower it, you are changing the volume uh, between your site and the reference surface, the existing ground, by 93 cubic yards. Okay. So what this does for people, I was working on a job in Owego, New York. It's in upstate New York, about midway across, say, the state of Pennsylvania, but then goes straight up Pennsylvania and then just pop across the state line there. It's on that, what they call the southern tier. And we were doing this work for Lockheed Martin, and they were building some new facilities. They were building some hangars that they were going to um, do some electronic installation work on helicopters. In fact, it was the president's helicopter that was going to be, the fleet of helicopters that they were going to be working on. So they were building a new 8-bay hangar facility. Well, Lockheed Martin had their own architect on site, and he was sort of guiding, what he wanted, telling their company, we had our architects and we were working, and they had a contractor actually out there on the site, and we looked at all kinds of things like, polluted soils and where's best to place it, all that good stuff. We finally found a site where we started doing all the grading design, and the architect said in one of the meetings, he said, well, that's all good and everything, but this is sort of our pride and joy. Can't we, can we, can we make it like, so, because when you're coming in from the main road and you're winding your way up the hill, and you don't really see it immediately. Can we raise that like can we just raise the building, say 2.5 feet? That wouldn't make it too high off the site. And the contractor said, yeah, sure. And that would be $5 million additional. And the architect goes, what? What do you mean? And because the contractor had this number right here, he knew what that was. So 2.5 feet of rise in height. He knew this number for his calculations. So 2.5 feet is he knew every 1/10 of a foot what it was going to involve material wise. So 2.5 feet, that's 25/10 of a foot. So he knew how much material. He just multiplied that, back of the envelope in the meeting, times 25. And he knew how much it cost him to haul so much dirt. And so he said, yeah, that's, a simple site. You raise it 2.5 feet, you're not just raising your building up and putting it on cinder blocks. You're actually raising the whole site by 2.5 feet. And that's going to start to run into money. That's why you balance those things. So, um, as a designer or even a contractor, those are really good numbers to know going into a meeting. All right. Now, let's look at this in conjunction with some of these other methods and show you how they compare. So I'm going to, instead of just exiting, I'm going to choose this button that says output to the screen. And I'll just take the defaults here, and I'm going to come over here on the side and just going to put a point there and hit enter to set it up as no rotation, and now hit the exit. So there is my volume, 2 volumes by triangulation based on prismatic volumes. There's my 2 surfaces, you can see, and those are the numbers. All right, so let's do this another way. Let's go back to surface, and let's choose volumes by triangulation. And oh, by the way, there's a 3 surface volumes for you folks dealing with multiple strata, particularly those underground things like, where's the coal kind of thing that will allow you to do 3 surfaces at one given time, and that would normally be done to compute things like excavation amounts down to bedrock, etc. Okay, so instead of that 2 triangulation surface volumes, let's do a 1 triangulation surface volumes. Now this would be what is akin to doing it by those stockpile commands. In fact, you can do this, and let's choose the stockpile as their surface. And so when we choose that, he goes, okay, well, I need to know what to compare that against. I can either go by a reference elevation, and I could type in here, if it was relatively flat and I just had a nice, good, even average elevation, but we went from like 379 up to 396. So we really weren't all that flat underneath that, um, or level. So I can't really use that as an option. And that used to be the only option that we had. But then Carlson said, well, you know what? Let's just use the 10 perimeter. Well, guess what? We calculated that surface and called it the base. Right. And, so we did all that stuff sort of manually on our own. But Carlson's doing all this and says, all right, you've computed this surface called SP. I'm going to just look at the perimeter of it, and I'm going to make this surface for you in memory. I'm not going to, bother you with picking all the crap, and I'll compute the volumes and kick them out. So I'm going to use that as an option. I'm going to say, okay. Same thing. I'm going to keep everything the same here, and I'm going to say, okay to that. There's now my numbers, and I'm going to do this output to screen, and uh, we'll do this one as well as, let's find this, and let's take the move last. Get these basic roughly on the same line so you can see them. So now here is our computation using that perimeter. Now look and see the difference. When we did it with our carefully made surfaces, we come up with like 3,300 and some yards of material. It's telling us we got 3,265 yards of material. For largish stockpiles, that's really close enough, and it's not too bad. What's happened is when it did its computation using the perimeter around our file, the same way we did when we chose that 3D boundary, it didn't fit, it didn't change any of that little wrinkle up here in that corner. So that's where that difference is coming from. Had we not made our surface edit, we would have matched this same thing. We would have had, 1.7 yards of cut and 3,265 yards of fill. So that represented that little wrinkle up there in the corner. Okay, so that's relatively close enough. Now, if you look at the surface, and let's look at this stockpile set of commands. So first of all, I want you to draw a 3D poly perimeter, which we've already done. Draw the base break line, which is the exact same line, and then calculate the stockpile volume. So now the difference is when we do this command, let me see if I can say select the, it's not going to work here until I do something. If I go to help, Carlson help, and we're in civil surface menu, and we're looking for stockpile. Volume, well, it's not going to be there. Let's see, calculate stockpile volume. So what this requires is that, it's customized, but it's the very same thing we're doing. It says the final surface is calculated from all the other objects, points lined in, blah, blah, along the perimeter polyline, but not including the base break line polylines. Or he's only computing the base surface. So What you have to do is you have to put these on a particular layer name. And let's see, select stockpile, blah, blah. So pick the entity. I think you have to go through the exercise of drawing those things, and it puts them on. It puts those on the particular layers. But here's the key difference is that it's doing this with, instead of triangulation, it's using to these grid surfaces. Okay, so it's basically taken all this data. So we haven't done anything. We've only got this material. Um, so let me just freeze that layer. All right, so if I go to surface stockpile, I'm going to draw the 3D perimeter or 3D polyline. Let's see here, the perimeter show options, prompt for the slope. Wait, no, I don't need to do that. That is already done. 3D base break line. No, I don't, they may have taken away. It used to be those things had to be on specifically named layers. But I think actually they'll be all right if we just select it now. But what happens is when we do the command, just to compute the volume, calculate the stockpile volume, it says select the stockpile entities and perimeter. So I'll select everything here. Now, so let's see, select objects, I hit enter. And okay, so it says ignore zeros, use the lowest perimeter elevation as a flat base. Well, we're not going to do that. We're going to let it go as well. We're going to go ahead and keep that same density. And that should work. We'll say okay. Now select the perimeter polyline, which was that. And now notice it asks us for this. So how it's going to make a 3D grid file, which is different from a triangulation file. How many, or how do we set the grids? We can either set so many numbers of grids, or we can set the dimensions of a grid cell. Let's set the dimensions of a grid cell, and this should be fairly quick to set it 5 by 5, let's say. And we'll say okay. And now here's the results of that. Now we'll plot that over here and we'll see comparatively, and we'll put it here on this bottom part. We'll exit that. And you can see what it did was it built this grid over all of this information and sampled it at, and then made this assumption. So it gave us a tonnage of 35, 25, and a volume of 3264 cubic yards, whereas ours was 3364. And the other approximation was 3266. Okay, so they don't exactly match because they're done in different forms. And the different form that was that it used to calculate from compared to ours was that it made a grid file. We'll call this one SP-grid. And we will use, let's see, source of data, screen entities, or, yeah, that's fine. Burst distance, zero, polynomial, maybe inclusion, exclusion. Set the grid position, screen pick, and we're going to use 5 by 5. And that's fine. We'll say okay. So we pick the first corner. So come down here, get a lower left. And I get an upper right. Now set the inclusion. No exclusions. And select the points. Okay, so now it wrote the grid file called sp-grid. So if you look at that in our surface viewer, you can see the difference. So you can see that it made a surface out of sampling that every 5x5 rectangle or 5x5, rectilinear space. And so it's not all that smooth looking, because it's really sort of crude, and it only samples the data at every 5 feet, but still that's not a bad way. In fact, you can tighten that up to like maybe go at every 1 foot and get it tighter and tighter and tighter. So that's the difference in the gridding, but gridding cannot pick up things like curb edges and all of that, because it just, it doesn't know to walk along and follow those features. So we're going to use those brake line information. Excuse me. Excuse me. I'm going to use brake lines and such to model those and directly reflect them, as hard edges in our triangulated surfaces. But you can see how, those are very regularly spaced, even, and it takes each of those cells, and they're 5x5, and then it splits them into, adjacent triangles. So it still does come up with a triangle as part of that surface, but it does it by analyzing those four squares, or the square, the four-pointed grid, the dimension by dimension. Okay, so that's the difference, and that's why those numbers aren't exactly the same. So really what you could say is, how much material do you have? Well, you've got 3360, or you've got 3260, or you've got 3260. So now ours was a result of a little bit of a tweak on the bottom of the surface. So basically you've got, well, somebody says, how much material do you have? 3,300 yards, whatever. And that's, about as much as you can say about that, because there's not a whole lot of additional information there. Okay. All right. Now we are about 15 minutes late into getting our morning break time here. So we'll go ahead and take it now. We'll come back at 11, and then we'll start looking at what this roadway stuff. I want to point out, though, before we leave this area, what we were starting in was the end of that particular exercise in your book. And, up here, we actually even talk about, computing the volume of the stockpile. So it goes through all that in some detail, and it even extended on into, now we're going to put in a little borrow pit. Let's say that was a stockpile, but we needed to know how much to excavate to get so much material out of it for our particular needs. Okay, and so that goes through all of these different things that we're also going to get a chance to go through, but we need to step up into our road design. So we're going to pop back into here. I'm going to leave you these little exercise refinements for you to try on your own. It'll step you through those step by step. And then when we come back, we're going to be talking about this fundamentals of roadway design, and we'll pick up some additional grading tools as we go through this as well. Okay. So any questions that anybody thought of as yet? Everybody good?
Thank you.
Good, good.
Good.
All righty. You
Thank
bet.
you.
Go ahead. I'm sorry. Just that was it. Okay. So I'll see everybody back at 11. I will pause or stop the screen share. And then I will pause our recording. And so what we're going to talk about next is a little bit of we're going to have a little discussion here about the roadway stuff, and then we're going to step into those features and some grading tools as well. Okay. Um, so what we'll talk about when we get to the roadway design is this, and this is going to be the same. It's in your manual, in your training guide on page 59, and basically talks about how we design roads. And whereas the things that we've been doing before, these little, making the surface and everything, it's vertically oriented, right? So we're making a surface and we're computing volumes, one surface to another, and it's all sort of vertically oriented. And if we were to consider doing a roadway design alike in that same fashion, we might consider putting down, say, the center line of the road on the ground, and then we would offset the edges of the pavement and then maybe the face of a curb and the top and the back, and we just sort of do all this stuff by building edges out there in a particular model, and then we stitch all that together and make that a continuous surface, and we still are going to compute things vertically, right? If we were doing a site, with parking lots and building pads and such, we would do that again on a vertical basis. And to as far as our computations go, so we compare the two surfaces with the prismatic difference between the two of them on a vertical basis. When we do roadway design, however, roads are set up to be um, uh, related to, and in fact, they have to have an alignment. They have to have a particular pathway that is now at this point horizontal instead of vertical. And so to propagate our design of our road, we would start at a particular location and we would walk horizontally along that alignment, and then we would raise up or sink down based on the vertical profile of that road. And so we do all of that stuff in these individual slices. Okay. And so um, what happens when we start to compute volumes with roads now and the different materials involved, we take a slice through the earth, through that particular model, and we look at the areas of all of those pieces of materials. So we would take a slice through there, we would calculate up the area of the stone here, and then of the asphalt, and then the paving on top, and then the area of the concrete for the curb. And we write all that stuff down for the area in this slice. Then we'd go down the road 25 feet, we'd slice it again, we'd add all these things up again. And now we'd also have, by the way, some additional, the original, excuse me, the original ground surface that we're comparing it to. And so we would calculate the amount of area either over or under. So anyway, we have a bunch of areas. We've gone down a particular standard distance, let's say 25 feet. And so that area of the slice where we started, and we look at the area of the slice of all those same pieces of materials at the slice 25 feet away, and that area is going to be slightly different based on whatever the road's looking like at that point. And so we figure on average that if we take the average of the area of any given piece of material from one particular slice compared to the next adjacent slice, and then multiply that average area times the distance between those slices, that's going to give us a very close approximation of the volume of material between those. And that's why that process actually is known as the average end area, because we're computing end areas of these sections and we are averaging them, one to the next adjacent one, and then multiplying those by the uh, distance in between. So, and that's what it talk about here, this an alternative to average end area, uh, as an alternative to this average end area approach, we're going to start to use these where we're going to create all of our surfaces instead of using those slices, which it's going to do that to calculate some volumes, but we're going to be able to calculate surfaces based on some 3D tools as we propagate down those alignments. Okay. So we're going to take those and say, all right, use that to create a surface, stitching all of these pieces together. Right. So that's what this is talking about in here. So we're going to look at some of the things that we need to have. So here's our typical approach. This discussion above boiled down to these items here, is that we have to have a center line.
I just wanted to point something out for us folks in Illinois, especially the AML folks. Um, we, all the stuff that you did earlier with the stockpiles and volumes by layers and volumes by grids, we can use those methods as a way of checking our cross sections, because we still do cross sectioning or average end area methods as
Uh-huh.
the tool that we use for our volumetric calculations. So, I don't know how this will tie in to cross sectioning, but that's they still are part of our plans. They're still part of our, actually the volume by sections is the quantity that we pay, regardless whether they're slightly different
Mhm.
of the volume that we calculate with surfaces or stockpile. That is um, based on our provisions. That is the legal quantity that we are to use. So we still include cross sections in our plans. We
Okay.
generate them, with a lot of the commands on Carlson, but that's how we calculate our volume. So I just wanted to let you know that, so if there's a way where this civil approach would maybe help us do that better, that would be great. But
Well,
that's the way we still do it. We create cross-section files, as SCT files, and we create a center line file, and then we compare those two to calculate our volumes.
okay. And so
So
you can, yeah, you can do that, right? In fact, these are probably
yep.
the tools you're using right here.
Yes, they are. All
Yeah.
this,
So
yeah.
yeah, so that's absolutely fine. In fact, it might even well, especially um, since your projects are set up that way by contract anyway, and your requirement, your
Mhm.
deliverable requirements to have those generated from anybody on the outside, that's perfectly fine, and that's a perfectly legitimate way. The road
It's
designer.
Is the road design going to do something similar? Is it going to use that sections command, or is it going to be a
No,
completely
it,
different?
it does, but it does it sort of automatically behind the scenes. Let me let's talk about this because we've got we got the two. Let's see, who do we have? Uh,
Yeah, and I didn't mean to interrupt your
no, no,
flow.
no,
I
no,
just
no,
I just
that's
wanted to.
exactly, yeah, it's exactly what I needed to find out about. So Chris, um, Chris, you and
Yeah,
who's
me and Mike are, this is
Mike?
definitely what we're after.
Yeah, so you are probably going to need to look at that. So yeah, so let's look at these and Olga, what we're I was going to say, if we weren't
And
gonna,
that doesn't mean that we won't gain anything by what you, because I don't know what this section is going to cover, but for
yeah,
us, this
it's
section,
gonna,
this
yeah, Yeah, we're not gonna really have you know, a full in-depth thing here, other than you'll see these cross sections, we'll see them um, come into
Excuse me.
play. But it's more driven by
By the,
this, from these road tools, and particularly
okay.
this, road network. So it's not gonna directly apply on your analysis of a site necessarily, but it's certainly some tools. So I can, we'll pull back a little bit on that so that we can also focus more on that grading and the section-based stuff as well. Um, see, this is the problem. It's so much nicer if you could sit down and have a week worth of time to sit down and go through this stuff. It would be nice, but nobody can afford to take that much time off work or to pay for the to the cost of a class for a long, you know, for a week's worth of training. But anyway, yeah. So let me think about.
Yeah, just regroup. I just wanted to, for us, the section in command is definitely the one that, we use by far the most. We can use all the other tools that you explained to, double check or, to do some quick calculations. But for us, this cross-sectioning tool is the sections tool is the one we use. But if there's other folks that need to go over the road design, that won't hurt us any at all, because occasionally we do have to build a road, so it would be great.
Okay, yeah, and you'll see how the sections come together from that, but, and then, um, you know, and you get through your section. So you've got all of these, you know, the section editors and everything that you go through, from this. So it's all, it should, you know, it's all still, excuse me, it's all still tied together and related. Or the difference is when you're doing it as a road design approach, that you can set a switch basically that says, hey, when I'm doing this road, go ahead and automatically make my section file. So you wouldn't necessarily see that process of being made, but they just show up on the doorstep. It's basically what happens. So, but
Yeah,
anyway,
I've messed with it some. I've done a couple design templates on the road part, and to build a basic roadway. So it won't hurt any. It's just that the part that we use would be the sections part. But that's okay.
all right, well,
I was just wondering.
yeah, well, no, I really appreciate you letting me know that. So I'll try to pay attention here that we can get a chance to do that, when we get a chance. So, but basically here is, as you folks, I'm sure are aware, is that, you know, we have a couple things that we have to do a road design, whether it's on paper or whether it's with Carlson or whatever, is we need an alignment or a center line. We need a vertical alignment or a profile, and then we need some kind of a cross-sectional shape, which we're going to call a template to, for the road to follow. Now, in the simplest terms, the template that you would make could just simply be that top surface. It could be the top of the pavement, the top of the curb, and over and around the edges. But to make that more, excuse me, a little more complex, and this is why it goes into this end area or section-based computations, is that that surface that you define across that template is not just a single surface. It is a, you know, it's a slice of the model that has actual materials. There's material thicknesses underneath it, whether it's paving or subgrade or anything else that we might be using. So that's where we're going to, and we're going to start to see some of those template editing tools, which should be, um, you know, you can use them for roads, or you can use them even for just section-based designing. And then when we put all those together, and then you also have an existing surface to design that against, then that is going to be able to tie the edges of what we're doing back down to that original target ground. And so I say that, and that's why we call this optionally here in number 5, because you can actually process a road design without tying the edges back to any ground. It'll just build it sort of free floating out in space if you want. In fact, you turn those tie downs on and off, like when you go across a bridge, you don't want it to compute the material it takes to go across there. You just stop the cut and fill processing at those particular locations. All right. So what we're going to do is open up this other file and step through some of these real quick things here and learn how to use these editing tools. And there's a file called roadway design base, which we're going to open. And then we're going to see what is available there as well, because that came from Civil 3D. And that often will be the case for us. So what do we have here? Roadway design base. So if we look at our roadway design base and choose open, we're going to get what looks like a contour map. Okay. And in fact, if we hover the mouse or select one of the things, that the whole thing lights up, and we look over in our properties and we see, oh, that's not like a polyline, and it's not an XREF, it's not a block, but it is an AECC 10 surface. So that was a surface object that was created in Civil 3D as part of somebody else's work. In fact, this is the file they give you from Autodesk as part of the training data. And if you look down in here, there's all kinds of little errors that you can see. There's, these contours tie together because the contouring, we're not allowed to have split contours like that or like this. So, and that's just a little artifact that the computer puts over. We would clean that up, before we were to deliver that. We just kind of, get rid of those little things there and put some additional labeling. But anyway, we have this as a surface. Now, how do we use that as a surface? If we wanted to build our existing ground so that we can get some design built on top of this, excuse me, then we would, we need these to be, drawn polylines or contours at a certain elevation. And if I can even show you, I'm going to go into this little perspective view, and you can see it's now switched into, I'm thinking, into this perspective view. Let me see if I can try to get some of this. But now one of the things you may have noticed, and now what it's doing with all of these different viewpoints, I'll go back to this 2D wireframe compared to this, you see how that changes? In one case, it looks like just contours drawn. And if I look at this, and you notice it switches to displaying triangles, which would allow me to see that as a surface. If I, if I turn that on to show that up, but I'm just using the CAD views at this point. And that is a characteristic or a property that of that surface entity in Civil 3D that allows it to do that. But we need that to not be this strange object that we can't really work with. And so one of the things that you might see is when I go up like this, you see that sort of underpinning, looks like little fence that's been built there along the bottom edge. Now, if I let go of that, it's going to change. But if I hold it, I got to start back out in this shape. And if I push that up, so you see that all those little yellow edges, and that's also coming out of, it actually came originally from Land Desktop, because that was one of the switches you could apply to draw those. So anyway, the bottom line is we've got some
I had a quick question.
Yes.
on that, how do you switch the view so you can see that tin file? Because this is it. What command are you coming from? I can see that box that you're talking about when I
You mean
flip mine, but when
this
I,
you mean, or
yeah, when not that view, the one that shows you the triangulation. Uh,
like that?
yeah, how do you switch that?
Okay, so all I'm doing is in plan view, it looks like this.
Yes.
And I just rolled it up with my mouse like this. Now I'm holding the shift key and
Oh, okay.
holding the wheel on the mouse.
Yeah.
And then when I let go of that and it settles down into, it should snap into that view.
Not for me. It must be a setting,
Hmm.
or
What
well, maybe
version?
I'm not doing it right. Okay,
No,
I'll
no,
figure it out.
barely. What version of AutoCAD are you on?
2023.
Oh, well, that should work.
Okay, so you hold the shift key and I can see the one that looks like a slice with all the,
Yeah.
but,
What,
and then okay,
yeah, what does it, in fact, let me stop my share. Go ahead and share your screen so I can see it. And I'm gonna
okay,
look.
let's see. Well, I'm not listening to you on the same thing, so I can't, I
Oh, I
can't
see.
share my screen.
Okay.
Yeah, I'm on a dual screen and I'm not on my laptop, so.
All right, no
I'm
problem.
watching you via an iPad. Okay,
Uh,
so
okay.
okay, I will figure it out. I was just wondering if there
Um,
was something.
yeah, no, in fact, if you do, I mean, you don't have to hold the shift key and use the wheel. You can, if you just go to the view cube and say,
Mhm.
hit that corner so you get a perspective. As soon as it finishes moving, it should change. No, that,
Mhm.
uh,
It's okay. It's okay. It's minor. I can
it's
figure it
set,
out if there's.
it's a setting in Civil 3D. When you select this object, you define how it looks in plan view, in cross-section view, in profile view, and in object view or rotated, if you do like a rotation on the object.
Yeah,
Um,
yeah. I must not have it. Like you have it set up. Well, it's obvious I don't because I can't see it. But
yeah,
I was just
I,
curious.
yeah, I don't know what that setting is. It's something buried deep in AutoCAD. So anyway,
Okay,
well, good question.
thank
All
you.
right. So but anyway, the bottom line is if I want to build a surface out of this, even as out of contours, um, which is really all the information I have in terms of that are these contours. And see if I try to view this in my 3D viewer, it's nothing. There's nothing for me to see because it is, like I said, when I select it and I look over here, it's this kind of extended entity. Now I'm able to see it because I have, and maybe Olga, this is what you might not have the same as I've got. I've got what are called Civil 3D object enablers installed in my installation of AutoCAD. So I can see that information, although I can't work with it the way you can if you had that software. So I need to extract that, and there's several ways of extracting it. And one is what you would normally think of is uh, if you were to select that and you see the fact that it shows up, it all highlights, it's all treated as a single object. Well, you could explode it. Okay, and so if you explode that, it takes it down one level of complexity. So if I explode that object now I select it, well, it still shows up as a single object, but now look at what kind of an object it is. It's now a block. And that's the way Civil 3D and all those places create that object. Now, this is what happens on yours, Olga, when you roll it around, you're saying you just see it like that, right? So,
Yes, that's all I see.
yeah, so it's now lost the characteristics it had back when it was that AECC surface type of object. Now it's just a block. All right, and so I could explode that again, explode this block. And now I've got you know, a bunch of things down here on these edges. I've got, what are those? Those are actually 3D faces. In fact, you could see them as solids if you know, turn the shadings on. But let's just put this back to our wireframe. And now when I select this, I see that that is a polyline, and it's on a layer called C Topo Minor, and it has a color 41. So now we're getting somewhere. Here's another one called C Topo Major. Okay, so there's our index contour. In fact, let me go back to my top view. Okay, so, and it has an elevation of 125, you can see right there. And this one has an elevation of 130. So this is a 5-foot interval map. So I could take this and, you know, I would maybe get rid of, let's see if I can, let's see if that layer is by itself. It is. So I could just isolate those and, you know, I don't need those 3D faces and it's part of my drawing. I could do it like this. Turn my layers back on. And now I've got just these as drawn polylines. At which point I would need to draw the boundary, do a shrink wrap, or let the system create it for me. Go to my surface menu and do triangulate and contour and let it read these. And one of the things to do if you're reading from contour data, when you do that, you want to make sure you look at this section right in here where it says adjustment for source data of contours, and you want to minimize your flat triangles. That's the important part to do it. So it will try to honor the intent of the contours. Now, all that being said, I'm going to undo the exploding of all this and show you something else that Carlson can do to save you that effort of bringing all this apart. It is if you can recognize, I'm going to undo. I'll just take it all the way down to the total back finish and I select this. And if you learn to recognize the fact that when that's called an AECC 10 surface, that stands for Architectural Engineering and Construction. That's their designation for civil type and architectural type design software. And it is a surface. Well, that's our first clue that I've got something here that is of a civil 3D or at least some other outside origin. Now, if you suspect you have that, you can, and notice, you know, what looks like, you know, that looks like a bounded, you know, a polyline that bounds around it. It's not really, it's the edges of that object. And then if you explode it, it's all those little 3D faces all stacked up together. So you'd have to recreate it anyway. But me being lazy and wanting to find some easier tool, there's a number of things I can do with this. I can go to my file menu and choose import civil 3D or import civil 3D. And I could say, just a surface, or if anything else, if there were other things in here, I might want to look at all 3D objects. And that's really what I'm going to want to, that's the command I'm going to use. A couple other places, excuse me, where it is if you remember the drawing cleanup that we talked about yesterday, where we could scan for elevations, we set elevations outside of range and we said scan the drawing. So this shows 0 to 0. So it's not, you know, this doesn't exist yet at elevation. So that didn't do us any help. However, we do have right here a tool, convert civil 3D and LDD AEC. There's that AEC term again, contours and points into Carlson format. Now, I don't know that that will recognize this. I think it'd have to be extracted contours. But let me see if I choose OK for that. It's trying all that stuff. And Yeah, you see it converted one civil LDDAC surface to Carlson format. No points. All right, so now what happened? But now there is a polyline. There's a polyline. And did it leave me with, yeah, left me with those faces. All right, so there's that. But now I still want to have I need a surface file. So all that command did was it read the data. We'll go ahead and now undo all of that back. So it read the data out of this object and dumped it out as polylines at elevation. But it didn't do anything, didn't give me a file. I would now then need to stop and rebuild that file. But if I choose File, Import, Civil 3D, and let's just say all Civil 3D objects, now you see it wants to know these files. So I'm going to say if there are coordinates, I want my coordinate file to process. I'm going to call this one, we'll just keep it the same name, roadway design base, say open. And it's going to run through all of these different things you might see, you might notice some of the things it's doing. It's extracting stuff. And now it says, aha, found a surface called phase 6 original ground. You want me to create a Carlson 10 surface? I'll say yes. So it's going to ask me, okay, what do you want to put in? What do you call it? I'm going to call it roadway dash EG. All right, so it's going through and looking for other things, sewers and points and parcels. This is really the only thing it found. Now, if I look at this, I now have a polyline at a given elevation. There's 130. Over here is, another one at 100. So it looked pretty good. And I still have these, the faces drawn. Okay, so I'm going to erase by layer just to get rid of those faces. So they're now gone. I'm here, go back to my top view. And I have a surface. If I view in my 3D data view, my surface file viewer, and look at my roadway, and a couple of things I want you to notice. I've got the outline of that looks like it follows, and it does, the original shape of our data. And there you can see the triangles as they formed. Notice these big wide areas where you get these long giant triangles that form across here because that's all the information they had. They had the one edge of the stream over here, one edge of the stream over here. And so that was, as far as it knew, that's all the information it had to go on. And so it just made these giant triangles. So this is a really kind of blocky kind of surface. You can see once we start to look at some additional data. Let me add one more thing. Yeah, so it's these triangles in here. If we go back to that, let me there we go. I wanted to get those back just to see. Okay, so when I look at the triangles, in fact, I'm gonna get rid of those and go back. If I look at the triangles in my surface file viewer, one of the things that sort of gives some things away to me is anytime I see these long triangles that stretch across stuff and I look at the form, you see how these are sort of short in between. I can see the ends of these contours coming down here and then they come over to this side. And then they start jumping this big gap. And I was wondering if see, I guess it's you can see where you can see the shapes of where those triangle edges are. That's along one of the contours. That's the other one up. That's right in here. So I'm just sort of trying to make sure that there's nothing that I either have included or it should not have included. Now, my guess is that when the salesman at Autodesk put this file together to use for training some prospective clients, they didn't spend a lot of time on making sure things were necessarily all that correct. They've got like right in here where any of these little contour areas like this, I guarantee they're just flat out like tops of mesas. They're just flattened because they make flat triangles across them. And you can see in the surface viewer, like right in here, there they go, edge to edge. They're all flat across there because it's going across to the same elevation. All right, so no biggie, as long as you understand that what we have here now is a surface that was extracted from the Civil 3D data, saved out there to the wider world, and we now have that as a file to work against. We can keep these drawn contours shown here if we like. We can, fix these little inconsistencies that we are not used to seeing with contours. And this is just cosmetic, but it might offend your sensitivities to have them. So, and you see there's a couple of little gotchas in places like that. Like that would be something that I wouldn't show necessarily. Maybe that one would go away. And again, I'm just doing that for display purposes. I could also erase all of these and redraw the contours based on my surface, but let's just put in a couple of things for some visual reference. I want to remember all of those 3D faces that made that nice yellow boundary. Well, I'd like to see that boundary, but I didn't need all those hundreds of 3D faces. So since I have a surface file defined, I can go to my surface menu, down to the bottom, draw surface, and let's draw the surface boundary. Okay. And I'm just going to put that on a polyline layer called, I'll call it V for survey or existing, V topo boundary. I'll just make it a 2D and off it goes. And we'll read the surface file. And there it is. I will now go to the topo boundary. And voila, as they say in French, or Bob's your uncle, as they say in England. There we go. So we've got it now and defined. We didn't need to do it, but we've got something to work with. Now, in terms of roadway design and work, we've got, let's see here. This guy is 160. Is this also 160? Yes. So if I wanted to remove a polyline section, and then I could join this to this, to that. There we go. Just cleaned up again, a little more of that. So now as in terms of road design, we've modeled we've modeled our existing ground, which we didn't have to do anything. We just extracted it out of the original Civil 3D file. And technically, even from a legal standpoint, that's what we have to do anyway, because we're not allowed to modify somebody else's work, unless we, get some kind of an agreement worked out on whoever gave us this originally. So, but again, beyond the scope of this class. So if I look at this, I've got a polyline that represents what will become our alignment. I've got a start and a stop of my alignment. So how do I make that into my center line? Go to your center line menus, and there's a couple of choices. You can design a center line where you are prompted to pick locations on the screen, etc. But I find far easier is to draw the center line. In our case, we draw a polyline that represents the center of our road. And you can even at this point go in and choose to, put filleted circles in for the arc radius of the horizontal curves, or you can leave them as just PI to PI, because maybe even it's a sewer layout alignment. Maybe it's not something with curves in it. But in any case, if you draw a polyline and it's already there in the drawing now, all you have to do is choose polyline to centerline file. So that's going to read the polyline and turn it into a centerline file. So I'm going to choose that command. I'm going to give it a name, and let's just call it Main Street and Side Street are so overused, and it's got stuff left over from other work. Let's call this one Forest Drive. Okay, now reading the prompts, it says select the polyline that represents the center line, but it tells you a piece of information above. It says the polyline should have been drawn in the direction of increasing stations. Meaning if you know that, that's the way it's supposed to go, because you're trying to maybe recreate something, or you want it to start at, the start point and the stationing increases to the end point. It's just reminding you of that. So you choose the polyline that you want to use. So I'll choose that, and it shows you the current direction of that polyline, meaning the direction that it was created in. And it says centerline station. So it's asking for a beginning station, but notice one of the options is to R for reverse. So if you pick that and you really wanted it to start on the south end of the site and go toward the north, instead of starting in the north heading south, then you would type R to reverse and you'd see the little arrows change direction. But we'll take it as it is. It wants to know a beginning station, and you can either just take 0, or maybe it is something that's set, like say 13 plus 67.83. You know what it is. It can be something completely arbitrary like that. So we put it there, and it reads some information, basically, X and Y and Z, and it calls them LI. It knows it's a line intersection, and then press enter to continue. So now you have built a center line. You could erase this polyline and throw it away, and you've always got it to be able to redraw. So under the centerline menu, you see there is a choice to draw the centerline file, but we can also choose our centerline editor and then choose the file, or you can, as a shortcut, just double click the drawn polyline as long as you had link line work with center lines turned on. And so now you've got those 3 components. So as you're in this editor, there's a couple of things that that you can do. You can make these, make it bigger if you want. You can, you see I'm using the mouse, the left button or the wheel, and just like in the drawing, it can pan back and forth. Okay, so a couple of things that you can do. You see these little check boxes. If you want to retain let me, there we go. So if you want to when I stretch this, my screen gets all you see how the labels get all wacky? So, I don't know if yours would do that as well. It might be something that's just my machine, but anyway. We've got a number of things. You've got a starting point, which is a starting point number. We didn't have a starting point number, but we have a starting northing and easting, or we can choose pick and go out into the drawing and give it a different starting point, a different location. We're telling that we're using roadway definition curves, not railroad. And then we also say, I want to hold other PI points when I change the starting point. So if that's not checked, if you changed the starting point, the whole alignment in the same shape it's in would pick up and go to another point. But if you say hold the other PI points, change the start point, then the only thing you're changing is that one opening segment. Okay. You can also retain PI points if you remove curves and spirals. So if there were a curve in here, it could keep that and revert it to those segments intersecting back at that original PI. So all kinds of different sections here or settings here. And if you look at this little listing, as you click, you're going to see the different things highlight above. And if you double click or choose edit down below, you're going to get this little pop-up that talks about that one segment only. And so it shows you there's a starting point, easting and northing. You've got an ending point now for that segment. You can either pick a point number or you can pick from somewhere here in the file. And there's again end point northing and easting. And it has a certain length that's 362, 32, 74. If you knew what it was, you could type it, change it, and go to a particular station. You also have these little check boxes to enforce tangency on the previous elements. There happens to be none for that one, so that's fine. And then the format of the angle, and there's your bearing, etc. So that lets you edit that particular segment. Okay. In fact, I may have moved it a little bit, which is fine. And then you go to the next one. If you double click, again, you get the same type of thing. And you've got this tangential to previous, which you don't want that set now because you don't, if that becomes tangential to the previous, it just puts it all in a straight line. We need a curve or something in between there too, before we set that. So how do you get curves in there? Now, again, if we had curves, we could have, I'm gonna say save and exit, and I say, yeah, see, I clicked that endpoint when I looked at that. So I'll put it back where it was. So you could either, before you turn it into an alignment, you could do a simple fillet where you take this and you fillet a curve in there and it trims off those sharp points and adds in an arc to sort of fill that out. And it's a tangent arc in between it. So you could do a fillet on the polyline and then turn that straight into the alignment. Or, and I do this most often, is I just draw PI to PI and then I go into my centerline editor. And as you sit in between, you sit on this particular one, you're always going into the next thing you're going to be doing. So at this point, I can come down here to the bottom and I can fit a curve. There's a button there that says fit a curve. I've also got fit spiral. If I'm doing spiral geometry, I can add those as well. But I can fit a curve, and now it wants me to, pick any number that you know or desire that you want, and it will calculate the rest. So I'm going to say maybe it's a 250-degree curve, and I'll say okay. And so now there is my 250, I said degree, I meant radius, a 250-foot radius curve. I'm going to come down to the next line. I'm skipping ahead. And also, well, let's sit on curve for the new one that we make. If I double click it and I get this part up and I can see your choices here are to either hold the PC or hold PI points. Tangent to the previous element, you see now that's checked on. But notice also too something here. In fact, come back out of that. We'll come into it from this line. Let's choose another fit curve. Notice you've got these horizontal speed tables where you can actually come up with these differing, guidelines. Here's your tables, your 4% maximum, your super elevation rates, uh, excuse me, and your design speeds. And that tells you these minimum radii to use for safe design at that speed, et cetera, et cetera. And you can apply those, so apply that target. It says the previous target tangent is too short to use that. It will warn you there and it's going to use a minimum. Well, it's going to use the biggest one that it can fit. Well, I still don't want it to be that. I'm just going to make this, let's say 150. Let's see what that's going to look like. Yeah, see, that's a very sort of simple curve. So I've got a 250-foot radius curve with the first one. I've got a 150-foot radius curve with the last one. Okay. So that is an alignment. If I choose save and exit, and you keep your eye on the alignment on the screen, and it's going to redraw itself based on those changes because we had link line work with centerline checked on. Okay, so once that's done, we now have the first part of what we needed. We've got a centerline alignment. What can you do with that? Well, let's go ahead and choose station our polyline or centerline, just so we can see and keep track of it. And I've got these are set up from all kinds of things where you can set up the labels as to what layers and whether they're parallel, perpendicular, etc. Setting up the markers for the different things and PCs and spirals and all that. I'm just going to take the defaults here and see what happens. I'm using my forest drive. And when that comes in, it says pick or enter the station to label. Oh, sorry. There it is. So that generated, there's my curve data. Here's my PC. There's that 1357.83 that I started with. And I've got these individual stations. Apparently I didn't have the parts. So I've got some things. I'm going to choose load settings. I think I've got something in another class. Let's try the studio. Still not getting my ticks. I don't know why, but let's try it again. Marker. Tick. Half tick. Let's try it. There we go. That has our little station ticks. Now, this is something that it used to not do this. I'm going to go ahead and just get rid of this label. I don't need it. But it used to not do this, but if I want to station specific points, like there's my PC, it's at 16 plus 3307. So that's 2 decimal places that I want to see, but I want my stations out here to be, I don't need to see that .00. They broke it at some point and they haven't put it back. There's a setting that controls the number of decimal places you do for this, but they've also let it apply to these same labels out here. And I don't want those. If they're nominal stations, I'm going to prefer to have them not use the decimal places. Okay. Anyway, cosmetics at this point, nothing to get hung up on. You can work on that. Here again is another type of setting. So I'm going to take this outer one and put it out here, and I'll take this one and put it, say, I'll just line up the plus marks with the stationing so you can see what they are. So there's my actual end of my alignment at 2702.95. So now, so what do I have? I've got this alignment. I can see it's from 13 to 2,700, so about 1,400 feet long. Goes through a couple of curves. And what do I want to do with that now is I need to tell it, okay, that's great. I know where it goes left and right. I need to let it know how it goes up and down. I need a profile. So the traditional approach to doing that would be, I would go to the profile menu, and let's say we were to go to the profile editor, and then we would load this in and give it a name, and cancel that right now, but we would give it a name, load up the profile, and then design against it. But the first thing we might want to do is to see what this ground line looks like. So create a profile from surface entities, maybe just drawn things, or I have a triangulation surface. So I'm going to create a profile from my triangulation surface. Now, when you do that, it's going to ask you for an alignment to follow or the center line to follow, which we now already have. Notice some of these other sources that you can get. You can take a profile from a drawn 3D polyline. You can create a profile from a polyline that's drawn on a profile grid. So if you have a drawing of a profile and you wanted to recreate that as a digital profile file, you can do that. It will sample that against the grid and you tell it, what's the vertical scale and all of that kind of stuff. But generally you would say, do a profile from a grid or triangulation surface, and it's going to ask us for the surface. So there's my surface. I choose open, and now I want to link profile to triangulation. I'm going to say prompted. So what that means is if you change the surface, then it will automatically change the profile, or it will prompt you if you want to have it update. You can always go back and do that anytime you want to do it. And you've got all these other things that you can do. You can put in offsets left and right. You can actually have it read the stationing by another reference center line other than the one we have. So we'll say, okay, that's fine. Just take it like it is. And now choose the profile file to write. Well, for now, I'm just going to call this one Forest Drive, and it will give it a .pro, but I need to call this. So Forest Drive -eg .pro will be what will be created. I'll choose save. And now notice what it's asking us for down here. It says that we need to choose either a centerline file or you select a drawn centerline polyline. Well, I'm gonna type CL, those are the capital letters down there in the lower left. So I choose the centerline file, which was my Forest Drive. It gave me some information. It found, created so many triangles, blah, 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 and it found 240 profile points. So what does that profile look like? I go to my profiles menu and choose my profile editor and now choose Forest Drive, existing ground. There it is. Now, I expand this out a little bit so you can work with it a little better. That's the existing ground. I've got some vertical exaggeration going on right now that if I look at it without vertical exaggeration, that's what it looks like. But you get an idea as to, the shape of things. As you move this around in the editor, you can see up above, you reports the station, the elevation, and the slope at that particular location. Now, at this point, I'm in the editor that edits this file. So if I make changes, say, if I go to, this point right here, it reads it as exactly 96.00. Well, so if I were to make that change or wherever I was, it's right here. So if I change that to something else like, 99, you can see what it did is it just took that one particular point and raised that to elevation. And if I say save and exit, that's what I get as the existing ground. Well, I'm going to say undo. And I'm back to 96. So this doesn't really do much for me because I am looking at an existing file. I don't need to edit it because it is the existing ground. So I'm going to exit that and say, no, I don't need to make any changes. If I want to create my roadway now, I'm going to go to the profile menu and choose that same deal, profile editor, except this time I'll choose new and I'm going to call it Forest Drive dash FG for finished ground or anything you want. And now when that comes up, notice it's empty. So now I can start adding stations and elevations and all that if I happen to know them, or I can say, and I'm going to choose down here, I've got different types that I'm going to want. I'm going to want a road profile, but the key thing to help you at this regard is that you want to show the reference information against this edit. Right now, it's just, in a profile. So right down below here where it's easy to miss, it says reference profile and reference centerline, neither of which show up. So we hit the set button and let's bring in our reference profile, which was the existing ground profile. And the reference centerline we're going to choose as our Forest Drive centerline. So it links all of that stuff together. Now, I've got something I can start to work with because there's my station at 1357.83, whatever it was. That's where that starts, and over here's where it ends. I'm going to put my vertical exaggeration back there a little bit, and now I could say, let's go to station 1500, and let's give it an elevation of say 125. All right, so that's now ready to go. I'm going to go up at a 7.5% slope with a 150-foot vertical curve, except I don't have that in there yet. And let's make the depth 0, which means put it right on the ground. And now let's go up here to say 2200. Maybe I don't know the elevation yet, but I went 7.5% slope. Ooh, Did that wrong. Let's see. There we go. All right, so at 2200, all right, so the outgoing slope from the previous point was 7.5%. And oh, let's keep that at some, it keeps screwing up. Anyway, so you could put these in very painstakingly, um, point to point to point, and but we at least have something that we can watch and see. Okay. Now, I'm not going to belabor this at this point because I want to show you the Cadillac of this is when you get into the actual roadway profile editor. It's sort of a superset of this. And we'll actually come back to that now and finish this up when we come back after our lunch break. But you can see this is just a generic editor and it's got different types, generic roadways, sewer, pipe crossing, etc. And it's really used to be the only thing we had with it, but the roadway tools in civil, in fact, this is the only tool you have in survey, for instance. You don't have the civil roadway editors. And if you look back at this, at the previous design where we're starting to come in here, there's that very same editor. And then we designed our roadway using that, the same process, okay? Because that was all done with the survey tools. So we're going to be going, much beyond that because we're going to be doing our roadway tool sets. Here where I was here. So yeah, here. All right, so we're going to use a different editor and I'll show you the difference of that. It looks very much the same. We'll say exit, save changes, no. If I go to profile and choose, instead of profile editor, I want to go to my design road profile and use a road profile editor. And so specify a road profile file. Again, this will be a new one. It'll be Forest Drive dash FG open. It wants to know, see, it already knows that I need this stuff. So it's asking me for the center line and it's asking me for the existing ground. And when that comes up, it actually brings that me not maximize it, just bring it a little bit. So that brings the same thing down, but it adds a couple of key things to it. It goes ahead and it starts you off on the same elevation. In other words, depth is 0. For the start and the stop, and there's our ending, our beginning station, our ending station, beginning ending elevation, and it calculates the slope along that line. Notice it couples it to this little tracker in the horizontal or in the plan view, much like our quick profile did. And again, tone that down a little bit to in here, maybe. And there's a couple of other things that you might notice in this editor is that you don't have that other stuff about showing the center line, the reference center line, the reference profile. And you don't even have to create that existing grade profile beforehand. You could go straight into this, and when it asks you for the alignment and for the existing surface file, it actually goes ahead at that point and samples the existing ground and creates that as a profile file. If you go down here to the bottom and choose the setup button, You can see some of that happening in here, and it says output the reference surface profile. That was the one that we originally called -EG when we chose profile from triangulation file. But we don't need to fool with it with that step. This goes right straight into doing it. It does it for us. And if we check this on, it will create that file. So if you were to look in your folder next, you'll see that file right along with the other one. And so a couple of things that we've got while we're here, these green triangular markers that you may notice are from this show centerline special stations. Those are the PCs and PTs, or the type of event points that you've done. So they're going to show up for you there so you can see it at a glance when you're in between. So you see, watch the crosshairs in the profile view. I'm right there. Now look at the plan view in between. So there's the markers. Same thing over to this edge to this edge. Okay. Now what's the old highway department rule of thumb? You can't have any, or you shouldn't have vertical curves anywhere that you along a horizontal curve, because you run the risk of making a broken back view sight line where you can't see the road ahead, and yet you can see part of the road ahead that's further on, and there's a gap that you can see it. But in any case, we're not going to get into the niceties of state highway department road design. I'm just going to learn some tools here. So that's why you have those markers. There's a couple of other things that you can see if you look under setup again. And one is that if you show the reference surface, if I turn that off and come back and say, okay, so then now that took away that existing ground. Okay, but we're going to probably want to see it most of the time. You can also show that reference surface at the left and right and give an offset distance. You can show this one right here. Show vertical lines for intersection. Show your sag and crest points. So this vertical lines for intersection. Well, look at that. I don't see any vertical lines. I don't have any intersections. That's because this road is not intersected with another road. So this roadway editor can actually recognize the fact that our alignment crosses or intersects another alignment, and it will show you with a yellow vertical line in the editor where that intersection occurs. So it puts everything all together in one nice stop and a nice little editing session as we go through. And we don't have to come down here and type in stations and such. We have these little editing tools where we can start just graphically picking our vertical curve locations. Okay? So, and again, too, you've also got, much like in the horizontal design for the centerline editor, where you could go to those horizontal speed tables. You've also got here vertical speed tables that will set the incoming and outgoing grades so that you can have the proper sight distance and stopping sight distance, to maintain safety based on those kind of rules. All right. So with that in mind, let's go ahead and take our lunch break. We'll come back and finish this up and do some grading, and that'll be a wrap up of hopefully a nice week. Okay. Any questions to any point? Everybody good?
Good.
Okay.
Thank you.
Thank you.
All righty. Well, like I said, we're going to go ahead and take your full hour. Let's start back at a quarter after. I guess it'll be 59 minutes. That's close enough. So we'll come back at my time, 1:15. So wherever you are in the world, 12:15 or whatever, and we'll start things back up. Okay.
Great.
Okay.
All righty. So let's talk about some grading tools and how we go about establishing these grade items. We've already looked at yesterday and a little earlier today how we can elevate line work based on it crossing other uh, things that are on the screen. But you can also have it once you've built a surface file, you can lay things on the surface and use that to create some graded objects as well. In fact, if you were doing something along the lines of, say, draw a polyline, I'm going to draw a 2D polyline, and we'll put this on, doesn't really matter, uh, see any utility layers is yet. We'll call this, we'll put it on a layer water line. And let's maybe start from here and we'll go down in this general area like so, and maybe out to here and finally down. Okay. So now if we've just simply drawn the alignment of our water line, if we want to make that into a three-dimensional figure, we're going to go to our 3D data, 2D to 3D, this time by a surface model, which would be our roadway EG. This is our design file here. And it says select the polylines that you want to convert. Well, there's the one I want to convert. Right now it's 0, so I'm going to convert that. And it says, well, there's a couple of options here. I can add vertices at grade breaks, and that means everywhere the surface changes, I can put a vertex along this line, or not, to where now it's only going to put the end point wherever that surface elevation is, come all the way down here and put the end point down here. So it keeps that as a straight slope. And it comes down here to puts this end point there, and then it comes over here and puts that end point on the surface ground as well. Okay. So we can we're going to call that 3D water line. We will keep the existing, and we're going to apply a vertical offset of -4 feet to get below the freeze depth, right? So we'll say, okay, and there it is. If I look at my surface, or let's even just look at my 3D polyline in my viewer, and then we add our surface, which was our, sorry, wrong one, roadway EG. So now I can see that is the surface. There's my water line, which is actually 4 feet below, just on those two endpoints. And you see where it daylights a little bit right in there. Okay. So that would give you a sense of where you might need to put an extra joint in the water line, or even just lower its elevation at that point, is what have you. Now, if you look also at your profiles menu, remember that quick profile that we did last time? If we look at our not really screen entities, going to, I can't really, I won't really be able to pick that up in this tool. So I'm going to say we could look at that as a profile. We could draw that into our profiles and see where it comes up out of the ground and decide at that point to raise or lower that feature if we were doing a pipeline design for that. Okay. So that, and now if I wanted to, let's say, just drop it down an extra couple of feet, I mean, you could, but that makes it too deep up here on the top. So you might want to simply lower that particular point where it can, it's probably daylighting somewhere along this line in here. So if you lowered that, you could adjust those elevations accordingly. All right. So that's the difference of, we put that just on one single, or just on the vertex points of this line on the surface, dropped it 4 feet. We go back to that 2D but 3D by surface model. Again, our forest drive, or sorry, roadway EG. We choose this guy. And now this time we're going to add vertices at all the grade breaks. We won't put any vertical offset. We'll say, okay, there now is that one. And now notice how it has quite a bit of up and down. And we look at that in our model. And it's got, you see all of these different things, because everywhere that existing ground changed, it put in a little vertex to allow that to change. So again, just different ways of bringing some elevation into these otherwise drawn features. Now let's look at some of these tools that we're hopefully that you've been using or will come into use as you're designing your sites. And Olga, I want to have you sort of watch over this process, and maybe, we can talk about using these sections to compute the numbers when we're done with this. We're going to do just a couple of little pad designs and such, and see some of the tools, how we can combine these different things together. Okay. So if everybody has your file, let's go off here to the roadway, to the left of the roadway somewhere in here. And we're going to put in a little building pad of kind. So we're going to go to our, let's just draw I'm just going to draw a rectangle at this point and say, draw it like so. And that's going to represent my pad that I'm going to elevate and grade into this as part of my site. So if I go to my surface menu and choose design pad template, I've got several different targets. I can go to a surface file, which is what I'll do. I could go to screen, entities, or to a specific elevation. So if I were laying this on the existing ground and maybe digging down in the inside to a certain elevation, maybe I'm designing a borrow pit, that sort of thing. All right. So I'm going to go to a surface file, and I'm going to go to the outside. That happens to be a closed polyline. So I'm telling it I'm going to the outside if it's closed. And that should tell you that it doesn't have to be closed. So this works even though it's not necessarily always a pad. It could simply be an edge that you're going to project to a target. And you can do it with this command, or you can also do it with the 3D offset command. Okay. So we're going to now look at this. We'll design with a side slope ratio. And I'm going to uncheck all of these different things, except I want to round the exterior corners, and I do want to draw the side slopes and color them. Okay. I'm going to set my spacing to every 10 feet. And I'm going to set my corner delta angle to 10 degrees. I'm going to now make sure that I don't have any, I'm not going to do any trimming inside, all that kind of stuff. And then for my pad layer, I'm just going to call it pad for now. And I also want to make sure that I'm going to erase previous pad entities if I go back and make some edits. Um, But, and you can go ahead and do your earthwork calculations all in one step here, but we're not gonna do that at this point. We're just gonna see what's gonna happen. And I say, I'm unchecking this calculate pad volume, so what's going to happen is it's going to generate the 3D line work that would define that as a graded object, but I have to manually create that surface, and then I can use it to compute volumes and such. Just a two surface, triangulated surface volume comparison, something along those lines, okay? But I want to do that and then compare it with doing it by cross sections, the way Olga, you say that you folks do it at Illinois there. So I'm going to choose okay to answer that dialog box, and it says to pick the pad polylines. I'm going to pick the pad polyline, sound like Peter Piper here. I'm going to tell it the target slope, which was my roadway existing. I'll say open, and it says, okay, what's your fill slope going to be? You know, 1 to 1, 2 to 1, 3 to 1. Let's just go with a 3 to 1. And what about for cut? That will also be 3 to 1. And now it wants to know a pad elevation, and it comes up with a number. Now, where this number comes from, if you read the line above, it tells you that the range of the existing elevations at that surface you told it along that pad perimeter goes from 109.34 up to 133.55. And you can set this to be anything you want, but that's just reading to you what it is. So if we put it somewhere sort of in the middle, so between 110 and 130, we're gonna look at 120. So let's just make it say 120, 121.5, just for yucks. And we'll say, okay. And now it says, do you want to adjust any parameters and redesign the pad? At this point, you could, and it would let you go back and do it, but we're going to say no, just take what we got and contour the pad. Again, I'm going to say no. So I'm just drawing these elements. So if I select all of the 3D drawn elements and I look at those in my viewer, and for reference sake, I'm going to add in that surface and give it some transparency, see it a little better. Then you can see this in relationship to that surface. So the blue lines represent areas that are in fill. You can see there. The red lines are in cut. So that's our very simple little pad. And we've made a design. We have not made a surface out of that yet. That's just there to represent what would happen with this pad if we built it as such. So let's say, all right, we're looking good. We're refining our design. Let's go to our surface menu and choose edit pad design. So at this point, we're going to make some changes. And so it says pick the pad polyline. So I'm just going to go there and pick that pad polyline. And I think I choose that green one that was on that pad, that resulting pad layer. And it tells us, okay, here's your original slopes. All right, so let's say in my my cut bank, if I'm in cut, let's say maybe I'm in a good competent rock at that point. So I might go to a 2 to 1 there, but my fill, I'll go ahead and keep it 3 to 1. I could change the elevation, or I could also do this. If I choose balance, it's going to ask me, okay, what do you want as a target for import or export? If I keep them both at 0, that's going to basically balance my cut and fill. If I were designing this as, say, a borrow pit, or if this was going to be a disposal site, then I could give it some targeted amount. Let's say I needed 25,000 yards of material. then I would target that as my balance export and it would adjust this accordingly until it made that calculation. So I'm going to say, okay, and you saw the outline of it shift just a little bit. It only lowered it by a wee bit here. I had 121.5. So there it is. There's my report. And you can see I've got 127,009, 127,008, as far as cubic feet, 4737, 4735 in terms of cut and fill volumes. So pretty nicely balanced. All right, you can do a number of these different things. If you move the pad, it says pick a point to start your transition. So if I move it from where it is now to, let's say, I'm just going to put it over here. All right, so now it's moved, and obviously, I haven't done anything with it yet. So if I process that in my panel over here, it's going to back up and reprocess it. Well, that's going to be a lot of cut. So if I balance that again, you see, it raised it up a bit. I'm now up to 129.3175. So now I've got a nice pad sitting there. I can then exit that, or I could even at this point just say write the 10, and it would be exactly the same as if I had gone around here, selected this as my inclusion boundary, selected all of these 3D lines, which are the blue lines, the red lines, and the frame. So I'm just going to say write the 10 and let it do it for me. So I'll call that my pad. I've got several pads up there. Let's call it pad let's just call it pad by itself. Right, so now I've got a file called pad. I'll exit this. And now you can see it's going to be partially cut and fill. We'll just take a quick peek. Change our shading a little bit, maybe get an idea what it would look like. Display our contours, 35 feet. All right, so there it would be. It's in cut on the back side, it's in filled down here on the front side, and it's basically flat. All right. So we can do it like that. And again, it's a flat surface up here, so it's not going to necessarily, uh, wouldn't drain very well. So if we did another type of edit on this, if we edit our pad template and I choose that back and I can, let's lower, say, what did we, these are my high points here. This is a low point. Let's lower this corner so that I'm going to drain my pad down in that direction. All right. So if I say edit a vertex Z, it says pick a vertex to edit. Well, I'm going to grab that one. And right now it's 129.3. Let's make that 127.5. Say done. All right, so it's changed. I'm going to now process that, and you should see that change a little bit, which it did. I'll look at my report. I now have a slightly more fill than cut, but I do have a cross slope on it. Okay. So if I write this 10, I'm going to put that back to pad. And if I now view this in 3D, let's put our contours. Let's see if I can get enough to maybe There we go. It's 1 foot contour, so it wasn't very much. Drops to 129, so let's maybe uh, set that to a different slope. So if I draw, let's say I'm going to change this to if I know I want to go from this back corner to the front corner at a particular given slope. Let's say I want to make that a 3% down slope. And a quick way of doing that might be to say, we're going to draw a 3D polyline, and we're going to go ahead and prompt for the elevation. Right now, I'm just going to let it snap to that endpoint, and it reads that elevation down there on my command line, 129.30, 175. I accept it. And now where am I going to go? Well, I'm going to go down to this one and take that surface there, or that polyline vertex there. It's at 127.5. So I'm going to accept that and hit enter. Okay, so that's now at that same cross slope that you can see that we've made our pad. Well, let's see what that is. Go to my inquiry menu and then choose my drawing inspector on and off. And I'm going to right click and choose to make sure display polyline data is showing. It is. And now if I hover over there, I see that my slope is negative 0.58%. So it's relatively flat. So if I want to change that, you guys use your 3D editor much here at all? Well, I've seen some people that don't use that, but if you use this polyline elevation editor and choose this polyline, it's going to now show you there's that negative 0.58% slope, and I've got those two. There's 129.3, 175. It goes to 127.5. I've got them both locked as control points. But what I want to do is, instead of allowing that, I'm going to uncheck that one. And I'm going to put in this slope field right here. My slope into that second point is going to be a negative 3%. All right. So that now takes it from 129 instead of wherever I was before, 125. It's going to drop it down to 119.853. Say okay. And exit. Now you can do a number of things at this point. So you've got data that has now been modified. You've got the one white line that has been dropped down like so, but you've got this pad that's at this white edge that is too high, and I want to drop that down to that corner. But then I also don't want to have to go around and drop all of these blue lines down to it as well. But because I made that into a pad, I can make that edit and it will recreate all of those features. So that one was what, 119.85. And I could even just throw that away, go back to my surface and edit pad template, choose the pad polyline, and I'm going to edit my vertex Z, which would be, this vertex. And I'm going to put it as 119.853. We're done. It's now been changed. I now reprocess, and it resets that down. So you see it's lowered it so it's not so high up in the air. And if I look at my report, I can see actually now I've got 7,000 yards of cut and only 900 yards of fill. So I've got some ground to put away, or I can bring this back up and do a balance. All right. So I write this 10 now as my pad. So I've done all of that. I can, at this stage, get rid of some of this work. Now, one thing that you could have also done when you're designing your pad is under your design pad template, you have this option to use a slope pad design. And that's where you could have put in that -3% or whatever you had to do. And it asks you to define the direction of how that's supposed to slope when you go to build the surface or to go to build the pad. So you could do it that way. Either of these two ways is fine. And this would be having to go back and redesign the original pad to have that incorporated. A couple of other options that you've got in here as well is that you can choose this one here to process multiple pad polylines. Now, what that is and what that's meant for is, and we don't have anything set up to show it here, but let's say we've built this road surface, and maybe over here we've got a pond that we dug into the ground as another design element. It has its own surface. Then we put in our pad in right next to those, and we're going to say process all of these in multiple stages. So if I were to take this pad and try to target my existing ground, it might cut right through the roadway. But so we want to see where that's going to come in, and so we need to know which one was built first if we want, which slope that we want to prevail. And that's sort of the same idea as this multiple pad design. So we're going to have multiple pads. Let's come down here and maybe let's illustrate that pretty quickly. I'm just going to draw a couple of these. I'm going to now copy. Like so. So if I do a multiple pad design, let me get off of that and choose design pad template. Let's choose a multiple pad polylines. We choose setup, and it wants us to choose a particular order, and these are going to be as I load these up by layer name. Let's see here. Take this one out from the last time we used it. So if I still use a slope ratio, that's fine. Let me for my pad. So everything on that layer would become, and let me cancel this for a quick second. And let's change these items. If I select this one and call this layer, go to edit. I'm going to make several layers here. Pad 1, pad 2, pad 3, and pad 4. So I'll call this one, I'm gonna set to be on layer pad 1.
Could they all be on one layer?
I don't think.
Such as a subdivision with a bunch of house pads.
Yeah, that's the intent, and that's certainly it should work. So if I choose this, and let's just put these all on pad 1. Okay. And then if I've got, let's say another one over here. Let's do a Tuesday. We're gonna put this one on pad. Two. And we'll make it a different color. Let's say we did something like this. Let's not take it quite down so far that way. Let's see. I want to be 2. There we go. Now, so if we do a multiple pad, use a process multiple pads, and we're going to set these up. Let's clear that. Now let's add by pad. Pad 2 will be our first one that we do, and then we're going to add pad 1. Sorry, pad 1. So this should be how we can do that. We'll keep them just standard flat. And say, we're gonna put this on pad total. There is our existing ground. And now it says, select the pad perimeter polylines. So there's that one. And then all of these different ones. Let's go 3 to 1s, 3 to 1. Yeah, that's what I thought. It's gonna be around here. Let's see. 3 to 1. So what happened? Why do I have negative elevations here?
Did you give them any elevations?
You know, what happened was, under this. This. What's that at 0? These need to have some elevation. So if this one is, what is their elevation here? Let's say it's 95, so that one is 90. So we'll set this one at say 92. And that one we'll put at say 93. What is this? At 120, so we'll make this one at say 110. this. Also 110, and this is also 5. So we'll set both of those to 5, and let's see, I'll probably going to mess it up now. Let's try one more time. So if I design pad template, everything is set there. I've got my setup is correct. I'll say, okay, I'm now going to set my surface, and I'm going to choose this. And so it goes through and it builds this surface first. There it is. And now I'm going to say no. And it says, no, I'm not going to write it at this point. Onto the pad, no. And it won't. Process multiple setup is that, okay. So 3 with 3. No. No. Let's see what's it saying here. So if I go back and pick this one again and now choose this. So yeah, that's what is I? Let's see. All right, so now what you should see here is in a viewer when we see that. So here is this original larger one that was in cut. And this pad then would become in fill in this area, and it overlaps that one. So it's going to hit that surface. Notice it's come down here and it would hit this as a surface and not the existing ground like it's doing around in here. That's not all that. Let's see if we assess that. Let me see if I need to save it or not. Single pad, prompt for a selection set of pad polygons, and then cycle through and run the design on each one. There will be one final report. Okay, that's fine. It's all the way it's supposed to be. So I say so. And fine. Uh, Does anybody have
Would you not pick them all at the same time and they would tell from the layers the order of how they would tie together?
Yeah, I was wondering if I had to save the thing to begin with. So if I do, see, maybe that's as simple as it is. So there's the first one. So it did the first surface. And now it's asking for the 3-to-1. Now it's 3-to-1. So it's going in order. So I'm not able to change the order of these other ones on that layers, on those, the little yellow ones. That's in the order they were created. So if I needed them to be in a specific order, I would have to separate them by um, different layer names. And of course, you have different slopes. So there we go. And I'd say, no, I'm not going to save any of those, and we can see what that's going to result in. So go here and turn off my contours. So there you can see the original got built first. That was this larger one. And then these got built afterwards. So it used that as a target and not the original ground. The original ground was used here, but when it encountered the cut surface, it went up until it intercepted that. And then where it met the original ground before it didn't hit it, that's where it would create this little, basically a temporary target, as it were. So instead of targeting the existing ground, it's going to target the intermediate slope that it had created as it's going along. Okay. Now that is, let's go ahead and take those pads off of there. Let's see. So if if we use this idea, so I have a surface that I wrote here called pad. I could even contour that and see it show up here. But here's another way of, remember, we've got this down sloping pad. So if I want to put a ditch that starts up here and sort of collects flow as it comes down, again, we do that same type of thing. I'm just going to draw a 2D polyline, or actually, no, I'll draw the 3D at this point. Go ahead and set it on the surface. I'll not prompt, but I will use a surface model. And I'll say, okay. And there's my model now is my pad surface. So I'm going to say, put a line here, and I'm going to go down in this direction. And you see, I've got, I can come over to, say, this area, and let's maybe come up to, some kind of structure that we are creating to lay it on our surface. So that would be right on the surface itself. But if that were to be a particular something we wanted to put in the surface, now that it has the elevation set in 3D, I can go to my 3D data menu and choose change elevations and make it a differential. And let's say, let's drop it down, say 4 feet, and we'll choose this object. And now we're done. So if we were to look at that in our viewer, you should see that that's going to be sitting Oh, I changed it 4 instead of -4. My apologies. Anyway, we so -8. So now that's sitting down below that surface. Now, how do we grade this to come back up and be part of this surface to meet that surface? And we do that the same way with this design pad template. I'll go to surface and I'll go to design pad template and I'm going to, let's just put this thing in like such. We pick the pad polyline, we pick the surface now, which is pad this time. And let's bring this up at a 1-to-1, just so it's like a sort of like a ditch. And now we've got something that looks like this. Okay, so it's 4 feet under the ground there, and even though the ground was sloped, so therefore it's sloped, and then it drops an additional 4 feet. And now to bring it back out and catch this surface, it generated all this line work. We haven't made a pad, we haven't made a surface file for it yet, but if we do that either by isolating this layer and do a triangulate and contour, or even better and quicker, since we're using civil, we can just do an edit pad template, and it's a different pad. So we select it and we simply write the 10, and we're going to call this one pad trench. So now that one gets created and saved. All right, so we've got several surfaces working here. I'll go ahead and exit that. So how do we start to merge and combine those different things into different surfaces? This is a very good example of if you are designing, say, a parking lot, and a lot of people will design that parking lot instead of just setting the overall total surface of the asphalt, they'll try to do everything all convoluted in the middle. Maybe it's got some parking bays in here in the middle, some islands and curbs and such. The easiest thing to do is draw the curbs as 2D polylines. Go to your 3D data menu, 2D to 3D, by surface model, because you've already modeled the parking lot without curbs. You lay those curbs down on the parking lot model, and then you merge them once they're draped on that surface. That's a much easier approach of doing that. Okay, so the same thing, we're going to merge these two surfaces. So if we go to our surface menu and choose triangulation file utilities, that's going to bring up another dialog, and it will be, I'm going to load a 10 file. So I'm going to load my pad as the base, and I can color that in. So you see there's a lot of things that are similar to the 3D viewer. So there's my base, and I'm going to go to this next screen. I'll choose the button that says next, and whoops, let's go back to, there we go. So I'm going to spin this around sort of at my perspective. And now I'm going to say up here, I'm going to merge a 10. Make sure you don't choose up here the button that says add, because that's mathematically adding to the 10 by the elevation number. So we want to merge, not add the values. So if I merge the 10, I'm going to get several different types here, and you can find the nuances with that. But I want to do that. The second 10 is inside my current 10's outside boundary, and I'm going to create transition between them if I need to. And so you can do things like combine and repair the gap, merge it and recreate it, and history required, etc. But I'll take this as my default, and I'll set my colors so you can see them. Say okay. And I'm going to now add my pad trench. There now is what that would look like as a merged surface. I can now come down to the bottom and choose a save as. And we'll call this one pad combined. Okay. So it's now saved to that. I can exit that. I now have that as a combined surface here. If I take a look at it, there was my pad trench combined. And there you can see it was a much simpler. Now, I've got a couple of little things in here. You see those little jaggy looking contours? I can tell that's because I've got some long skinny triangles here. Now, how do you fix that? How would you resolve that in practice? If you needed to make that smoother, you need to make smaller triangles in here. So the easiest way to do that is to go back out into your model and put some line work in here. Go ahead and drape it, but put some line work across there and then say use that line work. Or you can also do these edits. Again, if we swap 10 edges, you're going to see I'm going to go to like every other one, and you're going to wind up, you know, sort of chasing your tail all day long trying to get these things to work. Because once you fix one, it breaks something somewhere else, right? So, you know, be aware of what those edits are going to do and and how they model things, whether they're correct or not. Now, very quickly, if we take a look at these cross sections, Olga, you were saying that when you calculate these volumes, now let's take a run. We'll put some numbers off to the side. So let's go to surface and let's look at our volumes by triangulation. We'll just use two files. So we're going to take the roadway EG as the existing, and we're going to take our pad trench combined as the final. And there's the inclusion, no exclusion, no need for tonnage, and we'll just say, okay. There's the numbers. We're going to put them out on the screen here, right over here. All right, so there it is by our prismatic method or vertical method. Now, so you were saying that when you all do your work, you're going to create cross sections across your site design. Is that correct?
Yes, it is.
Okay,
That is
so
right.
yeah, all right, so that's, and that is governed by what? Just by convention, because that's the way you do it, or is there a particular legislative reason?
No, I don't think it's legislative. It's just that I think that's how our special provisions are set up. So we calculate our volumes by the average and area method, and they've never changed it. So, and I'm not saying that is the best way, but that is the way that we have to do it.
Sure,
So
sure. Well, that's,
we,
yeah, that's not a problem, because I mean, I want to show you how it's going to work with this. I mean, you know how to do this. So if I, you know, what would I do first? I'm going to draw, let's just call it a center line. I'm going to draw my center line to set up my sections. Now, if you were doing this, to be able to represent good sections, you would say, try to be, you know, parallel to that structure there. So when you do perpendicular sections, you're going to catch the shape of that ditch. Whereas if you went this way instead, and you cut sections across like this, you might you might miss this little skinny piece. So you're gonna probably want, and you probably, I'm guessing that's what you do anyway, is that you figure out what's the optimum.
Yes, we try to set up our baseline, what we think is
Yeah.
going to give the the contractor the best layout of the site. Um, it's been my experience that you don't want to put a whole lot of turns on your baseline, because that sometimes that's makes, if your cross sections end up crossing each other, then that can skew your volume calculations. So
Got
but
Right.
I'm not, I'm familiar with that, but that, a lot of the new people that are coming on board, that's why we were hoping that we would go over that section portion of it, because while I have been doing it for a while, all the new people that are coming on board,
Uh-huh.
unfortunately or fortunately for them, that's the way they have to do it. So that's what, I was hoping that we would go into that section command, because that's the way we as a program are set up to do our volumetric calculations, which for us is our biggest pay item in a lot of times, because that's what we do. We move material, we move dirt,
Yeah.
or coal
Yeah.
refuse or whatever. So
Yeah, sure. And I mean, I will tell you that if you do this all the time, you probably, have a fairly good and deep understanding of it. Um, to the point, there's no real magic in it, and there's not necessarily anything wrong with doing it either. It's
oh,
perfectly fine. And I mean, it's not like it's more of an approximate method than say this method over here that we just did. Although it could be if you don't have your intervals tight enough to where you're going to miss changes. So really the workflow is this, like you said, you know how to optimize your center line to what that's going to cut the sections. And you don't want to try to cut things on skew angles. You're going to try to keep things like, in this case, there's my center line so that I'm going to pick up the shape of that ditch. Whereas if I, came across it like this, I'm not going to necessarily catch that, and it's going to skew my averages. So if I've got a line perpendicular here, that average area here coming up to my next section is going to be close to that same shape, and it's going to then calculate that based on the average and put it out to put it together. So it's pretty
we work on 1 foot contours a lot, which makes a big difference,
fine.
to some of the other, gradient work, or you can,
Now, well, when you say 1 foot contours, are you using the contour lines in the drawing to?
yes, sir.
Okay, so you're not building surface models.
Sometimes we do
Yeah.
that rarely. When we usually traditionally we get our mapping. Sometimes, like, you have to do, we do create our own surfaces and our own tin files. However, I would say 80% of the time, the contour mapping is, our basis. So, the
Oh,
drawing, we get that from the mapping company, and then we work with that. Sometimes, a lot of times the tin files are included when we get it. And sometimes we have to have additional surveying done, and we get point files or coordinate files, and we create our own 10 files. But most of the time we are given contour files.
yeah. All right. Well, I will say this, that when you have those contour lines, and if that's all you use for targets, let's say you do something like what you see on the screen here, and if you see where it ends right here,
Yep.
it wouldn't find any information there because it found this information, but it hasn't gone far enough to reach that. I need something to help define.
I unfortunately have found a way around that, and it is somewhat cumbersome, but nobody's asked me how to fix it. But there
Okay.
is a way around that.
Well, yeah, I mean, and if you like, if you elevate this line to 3D by crossing these places, it can extrapolate the previous slope. But again, that might not be the same slope. What I'm getting at is if you're targeting all of this line work,
Mhm.
just the drawn contours, you might start thinking about, even though building a surface from from contour lines is very inaccurate because you won't pick up things like this. That will show up as flat unless you put break lines in. So I would suggest you consider maybe trying to create those surfaces and use them as the targets. And even when you do your average end area, that still works fine, but you're not relying on it having to cross drawn contour lines. It can actually sample the ground, just like we saw in where was there section editor. If we looked at our this is the cross-section editor at each one of these little at each one of those stations, that's not a result of having intercepted those drawn contours. Those are results of having read that surface model at that crossing line. So you're going to always have data. Otherwise, when you do it independently like this, where you're relying on just these drawn lines, you have to go out and intercept those drawn lines. So you could still, if you go ahead and make a surface out of this information, you can still use your cross sections as a means of computing volumes. Okay, follow me, because that's exactly what those road volumes were. They were average end areas computed from those road sections. They were not computed top to bottom. I could take that those two surfaces. I've got the EG existing ground surface. I've got the overall total road surface. I could do just like I did over here. I could do that two surface volume computation, and the numbers there would be certainly within a margin of error of the numbers is if I went and added up all of those material volumes that I got out of my road network processing that were all done with cross-section analysis. So that part's not a problem. I wouldn't have any problem at all with somebody computing your volumes based on cross-sections, other than it is easier and faster, in my opinion, to just use surface comparisons. But and I can see going to the discipline of doing cross sections on the one hand, not just for computations, but if you ever need to draw it and see what it looks like, then you got it. But you've got a whole system set up with your contractors used to the fact that they're getting paid on those cross-sectional volumes. So that's fine. There's no real need to change that process. Okay, follow what I'm saying?
Yes, yes, I
Okay.
do.
So the refinement that I would suggest that you start to look toward is building the existing ground as a surface model, as a TIN file. And then when you create and can calculate your end areas, you can calculate them based on their cross sections, just like you always do, but it's going to sample the surface instead of relying on having to intercept those contour lines. That's really the only improvement that I would suggest for that. And if you would like, I'm going to offer it to you as well, Olga, because I know you guys, you had a lot of folks here, and you're sort of, listening to me, watching me sort of ramble on about road design and typical other type of civil land development things, which is important, and that's really the focus of the class in general. But I would offer it to you if you want to digest this, for a day or two or a week or whatever. Send me an email back and let's plan another session where we can just go one-on-one, or you can have your folks at your office or whatever, go through this and let's use some of your data. Let's use one of
Okay.
your existing
Yes.
files and let's go through that. I'd be willing to do that, give you say maybe up to like 4 hours and just as a follow-up session. I think that might be useful for you. And I don't want
Yes, especially for the new folks. For me, and yes, I'm sure I could learn something from it, but
Yeah.
especially for the people that are coming on board, going through, creating a baseline, creating a shape, a baseline file, and then creating existing and propose. And if they get in the habit of generating, 10 files and using the 10 files instead of the contour files, then or the contour, then that may be even better.
Right.
We traditionally don't use the 10 files. We strictly go off the coordinates because, like I said, we work on 1 foot contour intervals.
Yeah, so
And
they're always close enough together that you're going to hit something. You need
yes,
that-
for the 90% of the time, every once in a while, and that's very obvious when you plot your cross sections. You can, even if it's a large project, you can kind of go through and figure out, where your cross sections are not closing and why they're closing, and maybe make some
right.
adjustments to
Use some
to
interpretation,
kind of
yeah.
correct that.
Yeah, you can sort of read the tea leaves on those problem areas and sort of figure it out just by inspection. But yeah, I would suggest let's plan on doing that because I'd like to see what you have as a typical workflow. So if you will find a file that's a good base file and that has some typical work, give us a workflow and let's step through that.
Okay.
Let me see if there might be some efficiencies that we can garner out of that. Okay.
Yes, and like I said, especially for the new folks, I mean, they would probably greatly benefit from that for sure. Because I don't know that, any of us that are, currently working on designs have taken the time to actually sit down and say, this is, once you get your contour mapping, this is what you do next. That, we haven't gone through that in the different iterations on how you come up with a design. So at least going through this section, the sections command, how to use it, would be greatly beneficial for our folks, because that's all we do. I mean, occasionally, that road template, I have used it, but it is, very, very basic for us. Every once in a while, we have to, either rebuild the road or rebuild somebody's driveway or something along those lines.
Yeah,
But usually very
and
basic.
you can even use those templates. You uncheck
Yes.
left, same as right. You uncheck that box, and you can use those templates to design a site. You don't even have to design it as a road.
Yeah.
You can put it in there that includes, parking lots and islands and buildings and what have you. It's really sort of a kind of a strange use of it, but you can do that. And it comes right out of that design pad template because,
I'm gonna, oh, sorry.
oh no, go ahead.
I just wanted to second Olga on that. I think that would be very beneficial for us.
Yeah.
And I know she was interested in I think natural regrading is maybe something that,
The
she
natural
thinks that
regrade.
they would.
Yeah. The
And I
natural,
don't know if that's something you can be
well,
like,
let me,
is that like you mentioned that was like a complete different course
it's a
or,
different package. Like if I were to go to uh, settings, Carlson menus, and I would choose natural regrade. See, there's what that is. If I choose that, it tells me down here, it's not installed. I don't even have it. They don't even let me have it from Carlson to be able to teach with it. So
Oh.
it's a separate system. In fact, it's quite expensive. It's like 5 figures. Um, I don't know if that means $50,000 or 20,000 or something, but it's quite expensive because it's really some high end stuff, this geomorphology stuff, and it was developed by somebody's PhD thesis when they were getting in school. And I'm not trying to poo-poo it and talk it down because it's fabulous,
Yeah.
and it's even I think in Europe they even require that on certain reclamation projects. So it's it's well worth doing. And I would seek out looking at some YouTube videos that are addressing that particular topic. And in fact, if you go to your start,
well,
yeah.
I guess maybe at least I would like to see both processes, like you're talking about creating the surface and compare with the cross-section process of always talking about. Yeah.
Okay. So, this is all AutoCAD stuff. I'm looking for Carlson. Anyway. Yeah, so let's do that because see, normally in a situation like yours where you've got an institution or an agency that has, more than 3 or 4 people, actually we would typically set up a custom training program, and you can have any number of people that you want to attend the training for a single flat daily rate instead of a per student, per the cost of the class. And that's the other problem with these standard classroom classes is that, we have to sort of teach that canned curriculum so that, so there are other people that do site design and road design and they want to see that. That's what they're signed up for as well. So probably, that would be something if you ever wanted to extend that we would, be better off. You would be certainly better off. It'd be cheaper for one thing for you to choose some custom training. We can work right straight on your data, on your workflows, and ignore everything else that you don't do. Okay. So anyway, think about that coming up, and let's get back together. Send me an email. Let me go ahead and stop recording.